Welcome to the third day of 10th International Conference on Big Data Analytics. The date is December 21, 2022, Wednesday. So it is 9:30. We are going to start keynote talk by Professor Raj Sharman within 5 minutes. Okay, wait for the keynote talk. Thank you.
Standing here.
We are not informed.
From where we can.
Welcome to the BDA 2022 and both physical and online participants. My name is P. Krishna Reddy, General Chair of BDA 2022. I'm a faculty at IIIT Hyderabad. Now we're going to have a keynote talk by Professor Raj Sharman. The chair, it is going to be chaired by Professor Praveen Parchuri. He is a professor at IIIT Hyderabad. I request Professor Praveen Parchuri to introduce keynote speaker and manage the session. Thank you.
Thanks to Professor Krishna Reddy, and good morning to all. A warm welcome to our IIIT campus here. So today I'm going to introduce the speaker, who is Professor Raj Sharman from the University of Buffalo. The title of his talk is Data Challenges and Societal Impacts, the Case in Favor of the Blueprint for an AA Bill of Rights. So that's the topic. Briefly about the speaker, Dr. Sharman's research is focused on decision support perspective and on health information technology related issues. So decision support systems and health technology issues. So that's the two key focus areas. And this includes a number of topics, subtopics under these umbrellas. For example, online health information search, use of ambulatory EMR, resilience in hospital information systems, then simulation-based study for managing hospitals, emergency room capacity, and so on. Right. So there are a number of subtopics that are listed under these two core topics. Dr. Sharman's papers have been published in a number of journals, national and international ones, and he is a recipient of several grants from both the university and the University of Buffalo and external agencies. He serves as associated editor for a number of journals. Some of them are Journal of Information System Security, Journal of Information Privacy and Security, Springer Security Informatics Journal, and so on. So that's briefly about the speaker. About the topic itself, I'll just, so there is an abstract that is given here. I'll just say 1-2 lines and then I will hand over to the speaker here. So the topic itself focuses on the fact that AI as a technology has been growing in the recent times. So therefore, this particular topic concerns big data in the age of artificial intelligence. So that's the key focus of this talk here. And as part of this talk, the aim is to highlight the responsibility to create algorithms and automated systems that do not harm and are equitable and just. So that's the focus of this talk. So with this, I invite the speaker to start the lecture.
Thank you. This goes on. Yeah. First of all, I want to thank Dr. P. Krishna Reddy for inviting me here. He has done a great job organizing this conference, and with him there are several players who have contributed to the organizing, and so I am very glad to be here. Second, I heard some of the invited talks and keynote addresses, and they were superb. This, I say as superb because I go to a lot of conferences, and I get to see a lot of papers in different parts of the world. And I thought some of the keynote addresses made very good points, some at a high level, which you may not have captured because by training, it looks like the questions were more detail oriented. I say that very specifically because my presentation is at a high level. I subscribe to all of the presentations and I really enjoyed them. But it is really remarkable to see a lot of people ask very good questions to the keynote and the invited speakers. Also, the papers were excellent, but I was really surprised to see the level of training and the maturity that you have to ask those questions that you did. Thank you all for coming. My presentation today has two statements. AI is exceedingly good for us, but we must be cautious so that we drive our car within the lanes and there are no accidents. That we all know. And I think you agree with me on that. But what should we do? What can we do? That's where our challenges arise. The sociologists have screamed about the bias. They have also gone and seen how Amazon used AI, and a number of qualified people were rejected. I'm not going to go through the use case, which is in the paper, but there are many instances where there are positive use cases where AI has made tremendous difference in medicine. But at the same time, even in healthcare space, we find that there are biases in the way people are interacting with automated systems. Now, the AI Bill of Rights attempts to address and correct for that. And the White House proposal on the AI Bill of Rights is not a law. At this point, it's a guidance. But that's how things begin in the US. And then a lot of people who say we need to do something about it start getting into the rule-making body without the legislation. The different agencies within the federal government start instituting that. For example, this is towards the end of my presentation, not on the slides, but on the paper. I give an example of healthcare. A lot of people from a lot of universities write healthcare apps, mobile apps. Very good. You create very creative things. Let me turn the analogy to if you create a car, should you be allowed to sell the car and drive on the road? No country allows that because there are certain rules on the driver and the manufacturer and how you drive. Because if you create bad applications, it can cause harm. In healthcare, we've always had the principle of do no harm for the physicians, which is part of the Hippocrates Oath. We think that's a great oath for people who develop automated systems in healthcare. So what the federal government has done, if you want to sell a software, then in the US, you have to subject it to an FDA approval. And they test it for how risky it is. And they create several categories of risk. And if the risk level is very high, it gets subject to very intense scrutiny. And there are 3 levels that are there. I think what my advocacy is that we need to create more guidelines to make sure that our horse does not lead the lane. The AI does not lead the lane. I'm not necessarily advocating for new legislation, but in some sectors that may be needed. Now, let me give you this example of healthcare again. I use a continuous glucose monitor. So every time I eat something, it tells me how my sugar is doing. The information is of tremendous use because I can know, oh, don't eat for some time or walk around for some time, or this food will create a longer time to increase the sugar level, right? And some are fast acting. So you get a sense of it. And you also have that information that is personalized because when you eat some food, how your body reacts is different for different people. So the freestyle glucose monitor is very useful. It is a little bit expensive in India. I think for 24,000 rupees, you get 6 of those. And typically, devices are cheaper in the US, but I pay only $25 and it gives me 14 days, so $50 I get a month. Whereas you get an equivalent of $200 on this. So there is something that the government needs to do on the pricing of that. My work is not on pricing, so in this presentation, so I will keep out of that. What happened was FDA took 3 months to 4 months in approving it. So anytime you create legislation for safety to improve society, there is a cost. And the industry professionals don't want to increase that cost because sometimes it cuts into the profit. But these days, they pass that cost straight to you. So you have to think about, do I want to be safe and pay a little bit more? And that battle goes on for everything that we do, including when we put security, and in hospitals, we enhance the security and we create practices for ransomware. We are now setting aside, because there are no good solutions for ransomware, we're setting aside some X amount of money, I think 7 to 8%, so that if we get breached completely, we can just buy that insurance or pay off that. As many companies are following that path. So there is a cost to it. There are two sides to it. In fact, all of privacy, I listened to some of the sessions from of the Congress, and the business industrial lobbyists were talking about the cost to them. And to bring privacy to you, to bring in the right to forget. So that if you go to the physician and you do all your tests, they keep a copy of the data in their electronic system. There is a whole advocacy on patient bill of rights. So you have the right to forget. That means that the hospital has to delete your record. Building that right to forget, which is in the GDPR, which is in the CCPA, and India is also trying to bring that in, it costs. So every good thing, even environment, comes at a price. And we choose one way or the other. But the harm that can be done to society is quite extensive. And so my talk is positioned to convince you that we must do something about it. But the way I approach it and what can be done is not from a sociologist perspective, but from a computer science perspective, which brings me to my background, that I am at my core an engineer. I've done my BTech and MTech from IIT. I've done management and operations management quite a bit, and my PhD is in computer science. But I sit in the business school to look at the business value of each decision, because you might do clustering of whatever type, and you say, at the end, I'm looking at when you use NLP and I'm paying you more compared to somebody who's doing simple predictive analytics. Does the cost, the benefit of your extensive analysis pay for your cost? I mean, these are things we have to look at, and cost drives things. I say in majority of cases, yes. And even in small firms, medium-sized firms, they export the data to specialists who know deep learning. They do the analysis and port the results back. Should I employ machine learning specialists? If I'm a big company, yes. If I'm a small company, I still have a solution. Now, my talk was supposed to be at a very high level, but I had to add some slides to tell you there is a little bit of technical flavor to it. Okay, move it to the next slide and keep moving. So, every picture is not fake. I used to look like that about 5, 6 years ago. And the sugar was not properly controlled. And then I became very slim because you can't eat so much. And I used to look like this about 2 or 3 years ago. And because I was wearing the cap, the balding head was not so visible. But now you see it, right? So everything that you see is not fake. And at the airport, my biometrics are not okay. The guy was there, I'm taking the iris shot, and it's not matching. Actually, what happened was I had done a cataract surgery, so all that on the left eye. So he was going berserk. How this is happening? So everything that you see that is fake is not really fake, right? I thought I could reintroduce myself a little bit differently than telling you I went to this school and I published those papers and things like that, to just telling you and introducing myself through my work. And these are only some of the recent pieces of work. And in this paper, what we are doing, we are creating a classification of the reviews. So when you go to a physician, there are online reviews. Now the online reviews are typically of poor quality. But yet, if you collect volumes of data from a number of sites like RateMD and Connolly Castle and so on, you get a large number of. Now, why did we need to classify the reviews? First, many patients go to physicians based on the reviews, and that's typically the case with younger generation and older generation. Now, it's not typically fully a free market and your choice, because we have this giant called insurance. So if you have a PPO, you can go to anybody. If you have an HMO, then there's a list of physicians and you still have to make a choice. And so within that limited space, you can choose and you look at the reviews. Now in healthcare, we believe, and physicians believe, that patients don't know much. They don't know about it. And here is the reason I will give you, because you might think you know. When you buy healthcare, you really don't know what you're getting. If you look at a cardiologist, a physician might do a referral. He might know the different cardiologists. I'm assuming everybody is honest here, okay? The money-making racket aside. One cardiologist may be doing more stints, and another cardiologist may be replacing the valves. So patient knowledge is not sufficient, but still patients make decisions based on what they see here. So we classified the reviews so that if you say a physician has bad bedside manners, he can improve it. If he says there are problems in the front office, it can be improved. So looking at the reviews and classifying it serves as a useful purpose for both the patients and the practice. From the patient perspective, somebody says he's a great doctor, but his bedside manners are terrible. But the other guy is really good, but he might kill you. You choose where you want to go, to the nice guy or the guy who knows. I always say that about Bonvita quiz contest, right? In India, we have this disease from the British that if you have general knowledge about everything, it's great. Imagine this. Would you want to go to a physician who won the Bonvita quiz contest, or my friend who did his BTech and then MS in Urbana-Champaign and became an MD, a neurosurgeon? All he did was look at where the veins are going. He's a specialist. He knows engineering, he knows medicine, and he goes to robotics. That's the kind of guy you want to go to, compared to somebody who spent his time trying to learn where the rivers are flowing and things like that. You can do both, but time among intelligent people has to be spent properly. Just layout. Now, we did a number of algorithms to analyze the reviews. I won't go into the detail because this is not what the presentation is about. It's only an introduction. And we manually annotated the reviews first. You paid $15. I paid per review. 3 people. And then an inter-rater reliability issues were dealt with. And machine learning algorithms, you have to have some data source from which it learns. And this became a challenging problem. How does the machine learn get clinical knowledge? So we got this, and there's a lot of effort that has to be taken. In terms of scheduling and appointment keeping and rudeness, you can get some data for the machine to learn. And this is very important to get right. Second, we went to Harvard Medical School and got their transcripts for the machine to learn about clinical terminology so that the machine is more intelligent. Of course, once you do machine-based unsupervised learning and you have some supervised learning, you can always do the comparison. You can use a number of algorithms, some trained and some that are already trained for you. Don't want to go into that. I think I might have a slide, but I'm going to skip through it. the key aspect is, and let me see if I have, yeah, this is good. When you do the subclasses, so in the beginning, we started with reviews, classifying them as clinical and non-clinical, and then we created a hierarchical classification system. But the key aspect here is that a review might belong to multiple classes, and you're looking at thresholds. And we are planning to do a game theory kind of mechanism for threshold setting. So even though you may not want to add extra layers or change the way BERT works or do something, you could still bring in OR in terms of threshold setting for different things and game theory. So that the contribution of the work comes from a slightly different space, but it contributes to the whole machine learning algorithm and system. And these were some of the thresholds. We are improving on it. The paper, this is a work in progress. Though it got an early part of it got accepted at a conference, for the journal version, we have to at least make a 50% difference. So we're going there. Next slide. To give you another flair of my research, we developed a software. Next slide. Is it working? Okay, so this is ergonomy and for sleep apnea, so that you can do this treatment from home, and instead of coming to the practice and sleeping overnight and getting observed, they created devices. And we use design science research, which is how you create, like a software engineering, how do you create the software? That's where the contribution was. But here is the real impact. We created a real software that is FDA approved. There are, this has been installed in 16 states. And I think this 1500 is dated. Now we have 6,500 patients who are using it. So what we do has real life impact. What we do with the reviews will also have real life impact. Okay, so gone are the days where you think that I will do this research and it may not have practical impact. One of my students was really interested in qualitative work. So he went to online social networks. Now, when we first started this process on online social networks, the physicians at Buffalo, we very closely work with medical school. They said that we all know what STD patients need. And then we realized, and after the conversation, they realized, after they saw the data, that in a taboo disease or in a taboo situation, people don't tell the physicians everything. They only talk about symptoms, but people with STDs may have other questions. Even before they come, they're trying to investigate the symptoms and what they are doing. So he went through it and manually annotated and created a requirements doc, so that if we create a chatbot in the future, he knows what the user requirements are for people suffering from STD. Now, STD is a group of diseases, so we can actually go into the depths of it. And STD varies across countries, and how people speak varies across countries. Okay? Even among English-speaking countries like Australia, England, and the US, there are differences. So he did this work, but we were not satisfied, so we created a chatbot. And in this chatbot, we have data from authenticated sources. And then the matching of the patient to the appropriate content. There are a wide variety of matching algorithms. We searched Match.com, Shadi.com for their algorithms of what they did to come up with an optimization routine for it. We're still improving this product. And some of the other things that we noticed is when we go to a cancer site, when somebody gets cancer, then they go into deep depression, and this resonates with what you said. The grief cycle takes a certain trajectory. What we found and what we are doing, and this is encoded in something called the Kluber-Ross mechanism. If you have your phones or that, you can look at it. Kluber-Ross, the grief cycle. And we think that in STD, that doesn't happen, because many of the people who are caught regret it. There is no repentance. And our chatbot, therefore, has to tell them, share the information. So it's a kind of a social messaging that is built inside the chatbot, in addition to giving them the information they need. By the way, Star Trek and all the new and the old series had social messaging all through. Okay? You might have just seen it as Star Trek, but they ingrained a lot of social content into it. We do that with certain principles that are involved to improve society. Here, this is another paper where we're looking at chatbots and how do we measure chatbots. And we thought just looking at the outward features is not sufficient. So yes, the computer science part comes in, that OSI has this layer model, 7-layer OSI model. So we said, let's go for a layered approach. In different layers, what are the metrics? And in this paper, what we did was we went to all the reviews that were there on chatbots. Thousands and over 6,000-7,000 reviews. We analyzed them and we clustered them into different groups. And we looked at TOGAF, which has been the industry standard for static applications. And we realized that TOGAF could be enhanced. And we added few more layers to the TOGAF model using machine learning. And then, of course, we looked at literature as well as did a lot of interviews and then tried to combine them. We had 3 experts, but here, when you look at 3 validators, you always think that I must do inter-rater reliability. And we borrowed from the theory of conflict resolution, because we have done a lot of conflict resolution on how people must behave. It's a well-studied field. So we borrowed from there, and we found that when some expert is saying, no, this metric doesn't belong to this category, we went deeper into it, and we came up with something like a confusion matrix. Okay? And that's one of our kind of contributions in that paper of how we do it. Okay. Finally, this student, Sagarika, is quite bright. She comes from Karnataka, so shouldn't expect any less. Good engineering student, very hardworking. And we said, when we look at chatbots, when you look at anything, here's the way to look at it. Everything that you see is obsolete. Everything in life you see is obsolete. Sitting in a room like this, if you move yourself 10 years from now, it's obsolete. We might be doing different things. So chatbots, machine learning, are they really obsolete? Yes, we want to create a companion bot. And so we said, how do you create a companion bot? And we had learned that data is a problem. So I told the student, I'll pay you 2 months of your time. Go around and ask your friends how they created friends. She came up with a corpus. And what do you think the problems are? Bias. So then we said, no, we're going to, you biased it because you spoke and you didn't do a good job, you were leading. So let's create an instrument so that you can ask a set of questions. What do you think happened? The instrument is also biased, because as you ask other people, the way data is collected also could bias the algorithm that uses the data, right? Now we are getting better at it. And we actually, and how do you create friends is a very big question. We are going to work with diabetic people who are about 65 to 70, and we will start very small with the female population and try to understand how they make friends, how they continue the conversation, what do they have. We will create a corpus of data set, and later on I might tell you how we evaluate a data set, right? Everybody is talking about debiasing. And I just came from a Copenhagen conference, and maybe I should have asked them later, how do you debias without measuring the quality of the data? And we believe in management, unless you can measure, you don't know. And let's look at this problem. I got a haystack, and I put 10 needles in one haystack, and I put 500 needles in another haystack. You should tell me this is impure and by some measure. And there are some algorithms that are doing that for structured data. And there are some people who are doing for unstructured data. There are some distance measures for it. And Kenny Joseph, who graduated from CMU, who works with us, his thesis was on prejudice detection. And he uses what is called as affect control theory and some of the other distance measures to kind of find, and then that problem of how to collect data is one, but how do you structure this? I do want to go back to make one more point. What do you think happens with classification? Once we do the classification, is our work done? We build all the safety measures, and is our work done? The key distinction is that machine learning algorithms constantly learn. So if you have a computer science thing, like it's a tree building and tree expansions, tree pruning, you know that algorithm, right? So the classification is really such a system, and the trees grow in. And if you look at more recent ones, you will get a lot of telehealth type reviews. But some of the other things that are coming in on office bedside and all are going down. So you can see over time, and that is true for every algorithm that you put in. You are looking at creating a good program. And all of our systems analysis and design courses, and you look at Scrum Master and Safe Assign and all that, they are all geared towards creating a good product. But they are all obsolete. Those guys wrote the book 40 years ago. In fact, the database books have not changed. I know many of the authors, okay? Navathe and all that. Ken Kendall, they're friends of mine. I've interacted with them because I have lineage to Peter Chen, and he's introduced me to many of them. So, and Ken Kendall, who writes the systems analysis book, has a PhD from our institution. These guys have made money because the most efficient thing is do nothing and make money. So if you don't change your book and keep it in students, keep using it and studying the same thing, you make efficiency very high. You keep buying the book. But how much do they innovate? So the new machines, I think we need to rewrite our systems analysis and design. And here, so how do you create that? And I showed you here that we need to do due diligence on how that data is done. And we need to look at and teach people how to debias. So for everybody, once the program is done, you make sure that there is no bias. There are many ways to do it. You know one or two, right? From your dal making, right? When you make dal, right? What do you do? If it's too, you pour good data, some water in it and get that composition so that the KPIs are within the margins. So, but there are many other ways to debias. That is good. But we need to be teaching people here how to get good data, how to validate the data in systems analysis. We need to change the way we do it. And then second thing is that unlike other static programs, there nothing changes except the user yells, oh, my program doesn't have this feature, I wish it had it. this program is going to go, I've become very bad, right? Because somebody might be writing foul language and things like that. And you might have, at some point in the future, the category of foul languages, choice phrases. So post deployment, we need to bring in audit measures. We need to bring in continuous monitoring. And we know about this because when we looked at Six Sigma and the Deming cycle, how we were doing it, can we bring that here? So my advocacy is that when you look at AI programs, you need to build in not just when you create a program, but after it is deployed. And prevention is not about just creating good programs, but let's go one step further and say, let's get good people trained the right way. And we need to change the way we do systems analysis and design, because these things can be taken care of a little bit better. I keep telling you this, now I come to my main presentation, but most of the things I've told you, you already know. I've given it to you through examples. So you should really find the rest of my presentation a repetition, right? I've told you about bias and correction, what happens. But when you hear it twice, you might remember it better. So, good. First, AI is everywhere. And for some reason, my student helped me put this slide together. Everywhere. And it's doing a lot of good to us. So, I am an advocate for AI. But I am an advocate also for building responsible AI. And there are two pathways. I told you healthcare, we're doing the regulations because you can't do harm. And about a week ago, we had faculty members. I put up a panel because my dean has been putting me on this track. So this is being done to please my dean. He wants me to be a champion for AI Bill of Rights. And I said yes, because at the end of the year, there might be a raise. But those motivations aside, no, I'm sorry. My dean is Anant Iyer. He gave me many ideas for this thing. And he has 20 top tier papers, 9 management science. So he clearly is a very good researcher. He didn't ask me to do this, kind of mentioned it. I took it on with a finance professor, looking at, because loans and how loans are provided is an important factor from finance. So the two of us came together. We do a lot of fintech work, but we were championing the AI Bill of Rights. So I had about 4 or 5 professors talk about who are researchers from different areas, sociologists, law people, and things like that. And the lawyers are also interested in this because right now, if you have an automated system that does harm to you, how do you get remediation? How do you get justice? They will still use the existing laws, but they're not as good. So we want some rules and things like that. So everybody, the sociologists to the linguists to the architects are interested in data, how you characterize data, and the bias. What is this? Anybody? Just help me out. What is this? Have you ever seen this? Have you ever seen this? Okay. A lot of companies pay a lot of money to look at this. Okay. And the very basic thing, Gartner puts out in public domain, and they look at what they see 2 years from now, 5 to 10 years from now, 10 years from now, what are the different technologies that are coming. And if you look at what's going to become more popular, most of them are AI related. The trustworthy systems are there. The causal AI is there, where AI is used and machine learning is used for looking at causal relationships. And look for this word, this name, Susan Athey. She is the wife of Wido in Benz. Wido does a lot of econometrics, and he got the Nobel Prize last year. His wife looks at deep learning and causality in deep learning and a bunch of other things. Look for the next to the next to next Nobel Prize winner in causal. And they are so early, even before Gartner put it up. So before you dream of it, somebody is already there. And that's why when you come to know of it, they are experts. That's why when you see everything, you look at it as obsolete. How do I create tomorrow's world? If you don't create it, someone will, and you will be a slave to them. Yeah, a manager, or assistant manager, senior manager. We always pay you some money. We can pay you more money to work more hours. Right? So you should be here, your research should be here on this side. Doesn't matter if you're right up there. Now, by the time you come here, you should see a lot of literature on it. So the literature survey papers that come here have to have lots of prior lit reference, and ACM computing surveys will be there. ACM computing surveys also takes a little bit of work from here. But if you try to do much literature here, you may not find it because there are 5 guys or 10 guys doing it in the world. People have been putting lots of money into AI. How am I doing on time? Okay, so I can speed up. Okay, so give me a thing in 10 minutes. So that 5 minutes I wrap up. People have been putting a lot of money in AI. And the amount of money that they're putting into AI is growing globally. And if you look at the investments in AI, we have done some econometrics work with slightly older data. The investments by US and China and other countries is far less. So when you talk about China doing great, here's the problem. What do you need for the AI machine to succeed? It's going to different places to get data, large volumes of data to become intelligent. If I have to go to different places to learn, and yesterday, the Bank of America person was saying, they get data from many different touch points and many different sources. To get all that data efficiently into your system, what do you need? Very good infrastructure. Otherwise, you will get AI technology, you will not exploit it, people will not exploit it to the extent. So infrastructure investment is needed. That also includes human infrastructure, okay? Because the jobs will be, the good jobs will be in that space, okay? So that's why I showed you that. It's not just the investments in AI, but investments in your infrastructure so that AI machines can suck up machine data from a number of sources very, very easily. But it's still a wild, wild west. I had a picture of horses that I picked up from Google, and then I removed them yesterday because copyright, I didn't want to get that. So just replaced it. People are using, and if you talk about Bank of America, they're buying data from a number of sources. Who gave them permission to use my data? So the AI Bill of Rights is aimed also at when people take your data from different systems, and you can either consent or not. And if you consent and give your data, there has to be a trade-off in payment system. That's where we want to go. All of the news media that is paid and everybody is going to oppose it, but finally we'll get there because we will edge, scratch and get there. But we will get there. Already GDPR is there, right? Which was heavily opposed. And you're now starting on that path with the privacy laws and things like that. So you can't take my data. But in the Wild West, they used to shoot the Indians, they used to take the land, they used to do a lot of things. So in the IT space and the internet, it's people are taking what they want without consent. And that we need to stop. They're not concerned with harm. And that's also with how they built the early railroads and things like that. They decimated Indian villages, Red Indian villages and things like that. They weren't concerned about it. They were not humane. In the AI space, we are in that thing. We need to build guardrails and there are no laws. Yes, it helps innovation, but I think we can do innovation with some regulations. And if there are no regulations, we have some rules. Otherwise, we have some principles and we teach people to create good software. So that's where that comes from. And sure, there is a cost. Everything costs. If you want the place to be clean, you might create, one thing you can do is put all your garbage on the floor, or as in America, you put it in garbage bags and put the garbage outside. But garbage bags cost. So everything costs. You want privacy, it costs. And you want, how many people believe that we should go green? If you do, be ready to pay. Yep, you have to buy electric cars. We need to spend money to put electric stations and all. It costs, everything costs, but we might balance the greater good. And do no harm, I borrow from healthcare, okay? That's not the phrase that is used with that. I brought that in. And of course, with big data, we still have some challenges that we are not fully dealt with. For example, if you look at a terabyte of data and you try to use Python, Python does in-memory array processing and it will crash, or your 16 GB will crash and it will give you that Microsoft famous blue screen. So when we look at big data, we still have challenges in terms of some technology, the affordability, because I had 17 trillion bytes of data, megabytes of data. We submitted the first copy of the paper after storing it in Amazon storage, the cheapest storage we can find, costing us $1,000. And then between reviews, again, I'm paying for the 17 terabytes of data because I can't collect it. And it's adding up. And so research in big data and AI requires investments by the institution for large volumes of data. I suffered through it and paid through my nose for storing very large volumes of data. And I don't think that they still charge. Somebody wants to make money for me to store. So there are issues, veracity issues come in because you might have data coming from 2 different sources, and part of the data from each source may be good and part of it may conflict the other source. And how do you resolve that? Many issues with respect to that, but we're not finished with solving all the problems with big data. But big data led us to analyzing it in better ways and helped us create the machine learning algorithms and all, right? If you have 10 records, I can use my hand. If you have 100, 200 records, I can use the logbook. After that, I can use the slide rule. Then I can use computers and spreadsheets. Now I need ML programs, right? As the data volume increases. And when you look at harm, harm can be categorized into harm to individuals, harm to people, harm to organizations, and harm to a system. You can read about it, but I really want to tell you that the AI Bill of Rights that I was talking about comes from the White House AI Bill of Rights. And the slides that I'm going to show you come from NIST AI Risk Framework, which is being proposed for audit purposes. When you talk about risk, audit people jump in, and this content comes from there. I don't want to tell you it's mine, no. So the credit is given, and there is the thing. And they briefly categorize them to statistical bias, human bias, and systemic bias. And many times when you do regressions and things like that, if there are missing values, it drops the records. Now, typically, people who have low social determinants of health have missing values in healthcare, and your algorithm drops it. So then how do you deal with that? You can't just impugn medical data and create it. Synthetic data creation for in medicine, you might create synthetic data in other places, but don't come to medicine. So we really have that problem. And most of the algorithms, regardless of, they will drop if some of the variables are missing. So there you have to take care of that. And human bias happens quite a lot. And there's been a lot of discrimination. So all the regression that we have done on loan processing and things like that, up to now have been biased. We need to fix it. There are more systemic biases also when we look at historical data, and how to fix it. This is where our research is, okay? How to fix it. This is where you must focus. And how do you measure? And of course, I talked to you about data getting harnessed without your consent. We need to change the regulation. The commodification of people's data, because Bank of America is buying your data from many sources, including some government sources. And should they make money? And somebody should sell and make money off your data. Those are questions you can answer, and you can say, yes, people can sell my data and vandalize me completely. Good for you. Using automation regardless of what can we do? You can be a bystander and let people exploit you. You can do something about it. There are some devising algorithms that are there. You can go study the literature. But my student wants to calibrate the data. How do I measure the quality of text data and structured data? How? And Rich Wong from MIT started the data quality movement. He didn't start it, but he wrote the book on it and he became famous. There are a number of people who came after that and looking at data quality, but they didn't look at bias and how do we measure bias. So we are struggling with that as the next is. If the PhD student doesn't struggle, the PhD is not worth it. And then, of course, beyond bias, after you install, you have to provide incentives. And in the healthcare, government provided incentives, but in other industries, for people to invest in making sure that they are more compliant. You give money to schools so that they can start teaching new things. And I might take a sabbatical to write something on it in a book. We'll ask if I can get some partners. 5 minutes? Yeah. So compliance and audit. And NIST has a framework, and they look at technical accuracy, resilience. And this is part of the old paradigm, which we did. But we are going to explainability. And how do you explain? And what kinds of explanation would be good? There's a PhD thesis or a few PhD theses on how you explain that. Several PhD students. How do you do interpretability? This is also a PhD thesis for many people. And the context varies because you might have people with low cognitive abilities who seek healthcare and people who are very smart who seek healthcare. So interpretability has to be, there are theses in it. Managing bias, what are the different ways by which you can measure and eliminate bias? There's some literature on it, but it's the starting point. Safety, of course, so that how do you detect whether harm is done? And if you can't measure, you cannot manage, so you need the measurement of data, the measurement of the applications. And we can go to prevent, monitor, and correct. This is borrowed from our old production and operations management, Six Sigma, DMAC. And I think we need to bring this into teaching people systems analysis and design and bringing these things into it. The books need to go. The guys are very, very efficient in making money. And of course, I've said education, prevention starts from there. And actually, one of the prevention things is, do you know Meta? So one of the CEOs of an healthcare insurance company was asking me if we can build some things in Meta so that the 13-year-olds and 14-year-olds, we can tell them about preventive health and preventive things, starting very early on it. Good systems can become harmful systems because, as I said, in the reviews, somebody can use language that is very unparliamentary and you might want to prune or do some things. But systems can degrade or system performance can improve. It can get better and better. I can tell you about Grammarly. I pay for the software. And it allowed us to do corrections. And all of us got together and started putting wrong things and all into it, just to see what would happen for a paid software. And this software started degrading. And we stopped doing it and the software is now stable. GPS, right? What do? On an afternoon, you're doing nothing, right? Take 25 phones and run on the street and then stop. What does the navigator do? It will route people across. Then you go through a congested place, the 20 phones, and take it, walk through that congestion. What will happen? It sends more people. You can destroy those apps. Research is needed. And of course, I don't want to go here. and you can understand bias from the business understanding perspective. There are papers in this space for data understanding. There are some papers. Remember, I just put one paper, but there's more literature. And in each space, you could do a lot of work. Each space, the research area, in all of these stages. With that, I think, where's my thank you slide? Okay, I looked at a lot of literature to create this. That's me. I have, even though I am, this is last year, I have fun, okay? And unless you have fun, life passes you by, you get older. So don't do risky things. This was not risky, of course. It was a lot of fun. And that's my family. Thank you. We can finish really on time and your tea will not get cold if you don't ask any questions. Yeah. I don't know much, huh? Don't ask me very tough questions.
My question is studying bias is biased?
No. Why? What is bias? We don't know. Just like trust. What is bias? Changes with geography, changes with population demographics, and changes with time. So studying bias and what we consider as bias is not a static phenomena, and it requires continuous check of how the society's values change, and then look at the data and de-bias the data. And when you build systems, build it de-biased, right? And there is implicit bias, of course, and implicit bias. So there's explicit bias and implicit bias. And implicit bias, you may not recognize that you're biased. So putting together a team from different disenfranchised groups, they may tell you, hey, what you're thinking is a little bit cockeyed. And so creating diverse teams is also very important and is part of my lesson, because when we try to create teams in systems analysis, we try to create more and more experts in it. But here we also need a diverse set of people so that they can give us
De-bias.
Because the definition of bias is what? Fluid, right? It changes over time, it changes over people and things like that. We need to be cognizant about it. Yes.
Truth is subjective by nature.
No,
Where
truth
you
is, okay, that's a very different area of philosophy. When there are definitions that you create that are relativistic, then things change, like the definition of poverty. Now, the new definition of poverty, you will perpetually have poor people because you have defined that as the bottom 20% of the population. So regardless of how rich you become, if you're in the bottom 20%, you're poor. I mean, this is now, so it gives us work to do as programmers, as social scientists and things like that, and somebody to pity. Yeah. Correct. Correct. It does. It does. And first, bias is relative, right? So different populations have different notions of bias. Second, we may want to profile somebody so that we can give them medicine exactly what they need, right? So bias, the software that is specific and targeting certain groups, like sickle cell and black people, they're the only group that gets it, mostly 99% of the cases. So that kind of bias is good, right? So you have to constantly evaluate, and the calibration for bias is society based, right? What in this time and in this space is bias? And if your program has to become more global, then within your data set, you have to make changes. So I again come to saying, I really want to create a textbook, and also, I don't know whether I will, but there is a need for kind of taking all your software engineering books and things like that, doing a bonfire and getting warm in winter, and creating new books. Teachers teach the same things, books teach the same thing. I know these people, 40 years, they've been minting money. You buy the book, like money. Yeah, we need to change. So my whole presentation today was about creating an advocacy and making you realize, but at the same time, telling you that there are research opportunities to go deep in it, interpretability or explainability. How do you do it? How do you communicate? It's not just telling them what it is, but if you're a certain type of person, messaging and structuring the message, and sometimes we may have to do something called emotional appeal. Sometimes we may have to do rational appeal. Sometimes we have to go into a combination of the two. Sometimes we may have to do the risk-benefit framework of communication. So communication field has a lot of ways by which we have to do things, right?
Yeah, I'm Shobhan Kumar from IIIT Harvard. I have a couple of questions for you.
Yes, sir.
You said when we gathering the data from automated system other than human, there is also a bias. So
Correct.
can you please tell us what could be the acceptable threshold for bias and how do you address it?
This is what my student is doing. There are many debiasing algorithms that try to calibrate the bias. Okay, so this is an area of research that is there. There are some debiaser algorithms that are there. So I cannot say here are two, and I don't want to tell you that because I think I have found limitations in those approaches as well, which means we have an opportunity to do something better, right? When something doesn't work, you can get frustrated, but there's an opportunity. And this space is very ripe for it. And it's harder in text than that. But there are people who have done some work on it.
So in the healthcare sector, one of the issues that we can foresee is, especially with genomic data and many of the other lifestyle-based data that's being collected, there is a danger of re-identification, even though you anonymize, you de-identify by removing names and other identification. For example, if I deposit a genome sequence, and because in my family, right, there will be 99.99% similarity. And so whatever traits that are inferred, now you are actually getting a view of the whole family tree.
Yes.
Right? And none of them have really given a consent or...
yeah, so that is where we have to work this problem. And there are good solutions that are both technical and non-technical. And that's why this space is like wide open for research. And we need to solve this problem. But I just want to add one thing. So a few years ago, about 10 years ago, so my daughters are very smart, okay? I went to just IIT, but they went to Yale. So, and they argued with the doctor saying that the insurance should pay for my gene. And they got the gene things. Then we looked at the risk, and the doctors were saying there's no clinical value. 10 years ago, no clinical value. And I am going in and saying, here are the risk factors. And if I can take care of these risk factors, I can do prevention. Then I go through my family and I find that some of the older people have fallen sick or they got that, and that was traced back to it. And information sharing laws have to come in so that if under what circumstances and how would you share your brother's information and things like that. That's for society to figure out where they will draw the line, and different people, and we might be able to create more mechanisms to do that. But preventive medicine today we are looking at as saying, okay, go for a walk and things like that. But we as a family have started looking at our genes, and we did that. We had to have a real argument with the insurance company, big time. Now we are looking at prevention based on genes. So all prevention, and it will become very popular. 5 years from now, lots of MIS and computer science researchers will be talking about gene-based preventive medicine, but we've already started doing it as a family. And I have some physicians in my class, and they agree that preventive medicine should really start with gene therapy. Getting people to pay for your gene analysis is different.
Yeah. Any final question from anyone else? Yeah.
I think I'll try to have two questions in one.
One you can have here, and one while I drink tea.
Okay.
I love tea. Indian tea is good.
One is, I think you have already mentioned, you need a large amount of data sets for AI to be successful. And most of the things with AI that we are doing, we do not have that large amount of data sets, like a companion bot that you had might have been a limited data sets.
No, we are collecting that large
Collecting
volume
data.
of data.
Large
My
volume.
army that
So-
I'm going to create will collect that data and we will annotate it and make it public. But our interest was to take a larger space. And I was just telling you about bias. But once we understand those issues, we will collect it for the 65 to them. There are so many issues in companion bot. How to create the conversation? How do you, just so many dimensions to it. We will just put one small dot, which you will need a microscope to see as this student's contribution. And then we will have other pins, and over time, we will have a better companion. The companions that you see are not true companions. If you accept them as companions, then sometimes they're movies and not really a robot behind them doing that.
Part of the question
She's not
was-
going to give you the mic.
No, the part of the question was, when you have a smaller data set, there was a possibility during the COVID, they introduced transfer learning, so that a small data set could be used to be able to predict. Would that be a good measure for AI to be successful?
First, when you have less data, what did you do? You use Bayesian techniques and you use likelihood methods on it. And then if you wanted regression parameters to be more robust, you went to more rigorous structured equation modeling or some other kinds of models that you build in, right? But if you give me 10 pieces of data, I can compute it. And by the way, I do want to tell you, we've been talking about agriculture. My father, I told him we're doing analytics. He asked me what we're doing. And I showed him the book. He said, I did this with agriculture. So he's 96. 95 going to 96.
It's very back.
So he did all this slide rule and all that computation. And at 90, he solves crossword puzzles. So if you give me 10 pieces of data or 100 pieces of data, why are you coming with machine learning? I just give it to you right here. No code, right? And I can write all that like xi minus x bar and all that I can do and give you principal components, regression, rotation. I can do all the underlying things that you're doing. And what is machine learning? Most of them. It's an old theory of curve fitting, where you fit a curve, you take the error term and you fit it back and you fit it back. And we kind of did this with convolution and first with Fourier transforms, and then we did that with wavelets and different kinds of splines. And then now you're putting the layers to do it. At some point, the coefficients become non-explainable. And in certain areas like banking and all, we can't use the machine learning. And in some cases, you can't use other techniques. Thank you.
Yeah, we have one more question here.
Hello. Yeah, my question is, the AI applications are using a lot of data now, but they are really in initial stages, and also we say a lot about bias, actually, right?
We are all in the initial stages of AI and bias.
That we have actually a lot of these constraints. What about the growth of building good quality, high quality applications? And how do we manage them in the longer run?
Sorry for using this example. A child learns to run after many days, and Rome wasn't built in a day. AI and data and our data sufficiency and infrastructure will take time. But if we walk that journey, we will get a PhD, we will get research, we will get funding, write books, and we can create a better world. Right? So, though my talk was a high level, I did give it. Now, I could have made it a very technical talk, but not for here. Thank you very much.
Yeah. So
Thank you for inviting me. Thank you, Professor Reddy. Thank you all. I appreciate the invitation.
Thank you. Yeah, I think we are done with the keynote talk. Thank you for your participation. So we have completed keynote talk. We'll assemble here at 11 o'clock for the invited talk by Professor Bapiraju. Yeah, it will be chaired by Professor Raj Sharma again. Please come back at exactly at 11 o'clock. Have a quick tea and come back. Okay? Thank you. Very well.
Thank you.
And now I was start working with Jillian, I would start working.
Yeah, our life is about learning new things.
Second part of the session. This will help us a lot.
The first part of the session I did last night because all of these guys said technical.
Welcome to the session. We completed the keynote talk. Now we are going. This session contains one invited talk and 3 research papers. I request Professor Raj Sharman to introduce the speaker. The speaker is Professor Bapi Raju, IIIT Hyderabad. So, Raj Sharman.
Thank you, Professor Reddy. I'm glad that you are presenting this paper. What makes the conference very good is talks like this. Cognitive neuroscience is at the cutting edge. When you look through it and detail, there are many opportunities for you to do research in. But that said, Professor Bapi Raju is a professor here in cognitive science and has been here for the last 20 years. He has also worked, he has also worked in Kyoto, Japan, and ESPRC in Plymouth, UK. And his work, and he's also worked in Trento. His work is in the healthcare verticals, so you can see a lot of connection with it. And I think we are in to hear a very exciting presentation. I personally think I am really glad. The quality of the conference is enhanced with your participation, your understanding of new research areas, and by presentations like Professor Bapi Raju, Sanjay, and other people who have presented here. Thank you.
Good morning, and thank you, Professor Raj, for introducing me. Also, thank Professor Krishna Reddy garu for inviting me to give a talk here. It's a great opportunity. While just 5 minutes ago, one suggestion came that I should, am I talking about iHub healthcare? I should have planned on that. So I'm happy that iHub Data is co-sponsoring this workshop. One of the 2 focus areas currently in this 5-year DST project that's into 1.5 years now, close to 2 years, is one of the focus areas is healthcare, the other is mobility. And there are other areas also, India-specific data sets, agriculture, and so on. Healthcare domain, I coordinate activities under healthcare. The talk that I'm giving is not related directly with that. In the healthcare domain, we are trying to develop, and I was quite happy to be sitting in the keynote talk, talking about various issues related to physician review, automated physician review, and various such. Of course, in India, we are dealing with much more ground level issues, such as developing automated application for detecting oral cancer at field camps. Right? So you have a phone-based image capture, and then you have a solution that is built based on data that's collected, and to see if the lesion that you see in the mouth is precancerous or cancerous. So there are projects like this that where the mandate, unlike in the traditional DST projects, because there are many faculty members sitting in the audience, the move in the funding agencies is to develop deployable solutions. So you say, I have 2 papers, you say, okay, fine, what more? Right now, the whole paradigm is moving away from just publishing papers and developing deployable solutions. It's all new, and I feel like I've just started my career again, right? So developing an application that is to be deployed in the field is never on the horizon for me, but it's all good, nice. Today, I'm not really talking about that. What I plan to do is an area where I work closely with students and have been for some time, cognitive neuroscience. And this is a joint work with Dr. Kamlakar. We both have a joint paper, survey paper in the proceedings. So all the references you can get there. What I will give is sort of a distilled 25-minute version of that. So as you know, cognitive neuroscience, there are two words here. Neuroscience relates to the brain structure and function. Cognition is the behavioral output from the human being. We are looking at human behavior. So the brain basis of cognition. Cognition is a generic word that is used. It also includes all the other things like emotion and everything. So the performance of human performance and the neural basis of that. And what is big data playing, what kind of role it is playing in moving this area field. So the typical process is that you give a stimulus to the participant. You have sensors that take up this signal. There are neural circuits that get activated depending on the type of signal. It could be a visual stimulus, auditory stimulus, or a smell stimulus, touch, any of these. There's a brain activation, and this activation is analyzed now in the last 15 to 20 years. There has been a paradigm shift, if you like. Within cognitive neuroscience, there are tools that are available now. For example, magnetic resonance image that can not only look at the structure, but also the function. Right? If you sort of put the subject long enough and make them do some things, you can get a snapshot of the brain every so often. Typically, currently, 1.5 seconds, you can get a whole image of the brain at a very good, decent resolution. 1.5 seconds, and you put the subject for 30, 40 minutes, and you get a lot of data. You give a task, and the next slide, I show you how this pipeline works, right? You have some hypothesis you want to test, and you create stimuli associated with that particular paradigm. You want to know what kind of for example, memory process. I show you an image and I show the image again, and if it repeats, you have to press a button. If it doesn't repeat, you press the other button. So it's a behavior that is keeping track online. Have I seen the picture or not? It's a working memory sort of task. So you design stimuli. For example, it could be face, it could be house, it could be a language related stimuli, or it is a calculation that you do. Right? You may have to do 35 minus 17, you have to hold it in your mind, and the answer comes next, and which panel has the correct answer or right answer or wrong answer. Right? And then while people are doing this, this is the image of a scanner, a caricature, the big magnet in which you let the subject, roll the subject in. They lie supine within this bed of the scanner, and their brain activity is monitored throughout this task. Suppose I'm giving a visual image, they look at the image and they have a task to do. And the activity that is captured, the brain activity is captured through this non-invasive mechanism. So this is what the earlier approaches use EEG electrodes that are put on the scalp, which is also non-invasive. The non-invasive methods of how brain functions have really revolutionized both the science of cognition as well as clinical practice. Otherwise, the other modality that has been used and is still used is PET, positron emission tomography, where a radioisotope is actually introduced into the system that you want to look at. And as the radioisotope decays, the detector detects how much decay there is in different areas. But this requires an injection of a radioisotope into the, and you cannot repeat because of the radiation hazard and so on. Right, so this, in that sense, this sort of paradigm has really come in handy, even for clinical investigation. So the brain response associated with this task is captured and visualized. So, so to go back, so now this kind of tool can be used for a variety of purposes. One of the areas of interest is aging for us, cognitive decline with aging. And what is shown here is a typical profile of what happens as this is a cross-sectional view, which means this test for working vocabulary, reasoning, spatial visualization, memory, sensory motor, speed. These tasks have been given to people of different ages, 20, 30, 40, up to 90. And what is plotted is the performance score, normalized score on this. And what you see, one striking thing, as you age, a lot of these things go down, right? Your sensory motor, speed, the memory, spatial visualization, all these seem to go down. But not everything is bad with gray hair. Right, this wisdom that is captured here. One thing that you see is going up is verbal knowledge. Your ability to use language and all that is either intact or it is actually improving as you go. So now the question is, what mediates this resilience of, say, verbal knowledge as but decline in sensory motor performance? Right, you want to understand what is the process by which brain circuits, right, so the are changing their functional connectivity, and with age, what is going down in terms of the structure and the brain activation patterns, and what correlates with different capacities. Verbal knowledge being intact and improving. What is mediating this sort of stabilized performance versus what is mediating a decline in memory, right? So these kind of things, and I'm talking about healthy aging. There are, of course, conditions where this is accelerated when there is a neurodegenerative disorder like dementia or of the Alzheimer's type or so on. There is an active degeneration process that actually subsides mitigates this. So that's a different thing, but this, what we are looking at is healthy aging, for example. So we'd like to find the neural correlates of this. Then you can use these kind of paradigms, right? You can put people in scanner and get the data in terms of brain activation patterns and do some analysis in terms of what is going down structurally and connectivity wise and what correlates with behavior and so on. Now, in this context, there are every country that you can name has its own human brain project, 10-year project, 20-year project. So one of those projects is a human connectome project in the US, where the idea is to collect large-scale data of people's brain structure, function, and so on. And thankfully, one of the mandates is to keep it this publicly accessible. And so data in this HCP, for example, current data that's available, 1,200 participants data, it's open T1, this is the structural image, morphology of the brain, and the function, resting state function while they are resting and doing nothing. And the other is task, like one of the tasks, working memory task or semantic disambiguation task or reasoning task, some of these tasks have been on 1,200 participants. This is a phenomenal sort of effort. This has been started about 10 years ago, and lots of paper being written, and you'll see some work that we have done on this. The other project is Cambridge. This is in the UK, Cambridge Center for Aging Neuroscience. They have 700 participants from 18 years to 80 years. There's data that's collected, both function as well as the structure of the brain, as well as some of the demographic variables and how many languages you speak, what's your some of the lifestyle parameters. All these are recorded, and this is again accessible. Of course, all these require you to actually make an application and state to them what is your research question that you are addressing. So they actually, based on the application and approval, they release the data to you. The other one, so I'm only mentioning some of them. There is a whole list of them in our paper you can look at. This is the ADNI data set, the Alzheimer's disease neuroimaging initiative. So this is healthy data. This is aging data. This is still not disease. Aging is not, right? It's a natural phenomenon. Here, the third one is a disease related data. On Alzheimer's disease, 1,600 participants, this across different centers. They have made all this data available. There is a UK biobank. So this ADNI is a consortium of participants from across US as well as Europe and Australia, New Zealand, and so on. UK Biobank is this mega database, 500,000, 500,000 people's data, and this is considered like a longitudinal data. They maintain this cohort, they collect this data over certain frequency, both demographic information, lifestyle parameters, as well as imaging. Imaging is a smaller subset, 500,000. Currently, they have scanned about 40,000. Right, so of course, imaging is costly. So, but the genomic information, unlike these three, this one also has genomic information and so on. So this is another initiative, Enigma. All these data sets are accessible for us, for researchers to work on. Enigma is a psychiatric mental health database. This is an initiative, as you can see, across the world. And you see one dot in India, this is NIMHANS Bangalore, which is contributing to, there are 29 disorders, 26 major psychiatric conditions that have formed working groups, and they collect data of varieties of information, both behavioral testing, the survey data, there is imaging data, all of this is. And I think in some cases, they also get genomic data available. So here, for example, this NIMHANS contributes to this for OCD, obsessive compulsive disorder. The psychiatric group that this is one, so far one database where I see something that is being added from India. Right, so this is something that I say right away as an opportunity for second largest population, and we don't have any contribution to any of these databases. And the other issue, I am jumping to my last slide, but is that there are specific conditions that happen that unless we wake up and create data sets of our own, these will not be taken up by any other country. For example, literacy and cognition, right? So we have a huge population that is not literate, right? But life really goes on very well. What is the link between a lot of data on cognition is on literate brain, people who can read and write, right? So this is, talking about bias. The whole world is looking at the brain that is able to read and write. Of course, we take pride as human beings. This is a an evolution, the top of the evolution, we are able to read and write. But so we don't have any data publicly available on what is the activation when a illiterate person does the same working memory task that a literate person does. Right? So there is opportunity. The second opportunity for India is multilingual. A lot of this data, I would say 99% of this is on monolingual participants, either English speaking or other foreign language. So, and India thrives with multilingualism. We don't have any data. And is the brain activation the same? I'm listening to an English sentence, I may be internally translating and understanding, or with 25 years experience, I don't have to do that. What is the activation difference? Right? So we don't have any data related to any of that. So I kind of put that right away as an opportunity. As a nation, we can contribute to this big data effort. And all it takes is an MRI machine, right? And you see one every corner now in India. So this slide gives an idea about the trade-off. There are debates in terms of what should big data and cognitive neuroscience look like. Should we have a lot of participants, like 100,000, and do imaging, or do we have 20 people but do a deeper imaging? Everything costs, and there are trade-offs. What this paper, this is a 2021 paper, what it suggests, so it's first highlighting those data sets that are large number of participants, but fewer number of data points or images. And the right-hand side is fewer participants, but dense imaging. Right, so still the debate is on. The group, USC group suggests we should do, of course, ideal is this, large number with large, but this is not going to happen. This is too expensive, and people have to, this NSD is a new database that is released. This is natural scenes database. So there's 70,000 natural scene images have been given. About 12 or 20 participants that spent about a year looking at these images, a year-long recording of data. So that's the scale at which you need to do. So obviously you cannot have 10,000, 20,000 participants doing this, right? And there are technical reasons as well. Especially in neuroimaging data, there is inter-subject variability. Intra-subject variability is very huge. I look at the image today, I look at the image in the evening, I look at the image a week later, I look at the image on a tiring day, I look at the image on a fresh day. The brain activation patterns are different. There's a lot of intra-subject variability, and inter-subject variability is humongous. So what this, the argument for this is that you can cut that down. You have fewer participants, but doing this over a long period, you can mitigate that factor, right? So, but anyway, this debate will go on. Finally, it comes to how much money you have, what is timeline in which you have to deliver things. So in the next two slides, I'll show you, okay, now the data is collected, what sort of other value-added tools that are built by community and that are given to the community, right? So now we are in the era of publicly accessible tools and data sets and so on. So this is one repository where you understand these acronyms now. HCP is Human Connectome Project, ADNI is Alzheimer's Disease Initiative. This is raw data plus pre-processed data that's given by the people, the consortium that has collected. But there are tools that are built. NeuroVault is all the significant activations are collected as a database, and you can do queries on this database and come up with so you can take the peak coordinates and statistical maps, and you can use this to do visualization. What is the average activation in this cohort when I give a visual stimulus, when I give auditory stimulus, when I give a language stimulus? What is the average activation that is averaged over several studies? So I'm not looking at the original brain activation, but the tables that are created, these are peak coordinates where it is. So you can process that, you can visualize them in multiple ways, in 3D brain image or 2D, all these. So there are tools that allow you to do this interrogation. For example, you want to see, you did a study and you want to compare normally what is activated and what are you seeing in your study. It's possible to do that. So this is another tool, NeuroQuery or a neurosynth is the old version. NeuroQuery is the tool that has all these around, I think, 14,000 or 15,000 studies that have, the neuroimaging studies have been deposited into it. This is the database that is created where you give a word grasping, for example. It will do a typical TF, IDF type of term frequency, inverse document frequency type of model, where it will find out what are the nearest words to grasping that are there in the database, right? Grasping, object, action, movement, action, observation, and so on. And it will project them into an internal set of the dimensions, object, action, movement, and their relative weights, and the activations corresponding to this, and a weighted sum of this is given. And so this text to image sort of query that is built on top of these publicly available databases. So many such things. This is a query that we fired, for example, for speech processing, for foreign language processing, foreign language learning, right? And it projects to internal dimensions, and it gives you the view of what is expected activation based on the 15,000 studies that have been done. What can you expect if you probe this, right? So this is the text to brain activation type of tool that is available. And there are 3 case studies. I'll quickly go through them in the next 3 minutes to, so 6 minutes, 2 minutes each case study. So these case studies talk about, given these data sets, what kind of things we have done, right? This is a study by Kamlakar as a postdoc in iHub Data, who is working with us in healthcare. His PhD work, where he took the UK Biobank study, 10,000 subjects, both imaging data and the demographic variables data. So the demographic variables, what you cannot read here, they correspond to mood related, lifestyle related, and other, right? So other factors. So you did a hierarchical, he did a hierarchical clustering and grouped these variables under mood and lifestyle and so on, and take this sort of this feature vector both from brain imaging data and the socio-demographic data, and used a supervised learning like a random forest to learn association between these features and some constructs like brain age or cognitive capacity, fluid intelligence, or emotional state. This is neuroticism. And so we built a model to learn this on this 10,000 subjects, both brain imaging data. Brain imaging data includes structural and the morphometric and functional connectivity patterns, and learn this model and use this these proxy variables to further predict how they are related to, through regression model, how likely, for example, their alcohol consumption or exercise pattern or sleep quality or smoking predict from these proxy variables. So this kind of model that was built on this UK Biobank data. So the next case study relates to encoding and decoding sort of exercises where we relate brain activity to cognitive function. There are two problems that one can pose. Given the stimulus, what kind of activity can we expect? Can you predict what activity that you are likely to see if you give this house stimulus, for example? Or you take the activity, can you predict what the participant was seeing? What stimulus from a limited set of stimuli, obviously. I mean, we cannot predict whatever under the sun, but can we predict the experimental condition that gave rise to this activity? So this is a decoding problem. This is encoding problem. With this large data sets available, we can begin to probe these sort of build models for encoding how brain encodes information, how and can we decode from the activity what information is stored. I'll give one example of this encoding model. This was presented. This is based on two data sets, large data sets that were collected. It's a reading data set. As subjects were reading sentences, there are a large number of sentences. Sentences go like this: clarinet is a woodwind musical instrument. These relate to different topics: musical instruments, skiing, or gambling. And within each topic, there is a concept. For example, this is violin or accordion, piano, all these different types of concepts within the topic. So people are passively reading, there is no task. And listening data set, this is another data set where people are listening to 82 participants listening to a story, Pieman story. And the story is, it comes through their auditory system, they are listening. And while they are listening to the story, the data is collected, 282 samples are collected. And the question that we asked is, the large language models, can they explain the predictive, can they predict the brain activity from the stimulus? Can we build a model to predict the brain activity while participants are reading or listening? So we used state-of-the-art transformer models that are fine-tuned for different tasks, grammatical tasks, natural language inference tasks, and so on, and looked at, so the stimulus is encoded, is represented in some form. This transformer learns it an internal representation. That representation is associated with brain activity. You have train and test splits. So you predict, give the stimulus, predict the brain activity, compare with the ground truth, and there are accuracy metrics that allow you how good this correspondence is. So we did this exercise, and what you see is the brain map corresponding to reading is different from in the left and right hemispheres. The predictive performance of these transformer-based models is different for reading versus listening. The listening related activity is mostly concentrated in the language area. Of course, right now this is the front of the brain, back of the brain. This temporal and frontal areas are supposed to be language comprehension areas, whereas in the reading, you also get visual area, as obviously because you are getting a visual stimulus. So we analyze these differences, but this is based on this publicly available data of reading and listening data sets that have been put out recently in the last 2-3 years. Right, so this was presented at Computational Linguistics conference this year. The third case study, the last one, is structure function mapping. Structural connectivity, as you understand, is the structural features of the brain. And the question that, the big question in this field is, how does function arise from structure? Right, so what is the link between the brain function and brain structure? And can we recover the structure? If I give you the functional activity, can you recover the structure, the underlying structure that may have generated this function? And to sort of gloss over the details, it's obviously not identity mapping. There is more function than structure. So structure function also is mediated by other intermediate regions. So since this is not one-to-one, it is a hard problem. And what we have done is built a model based on the graph neural network, attention-based graph neural network models, ensemble of them that are given the structure that learn to predict the function. And the comparison of how different the predicted function is to the actual drives the learning process, the supervised learning system that learns structure to function relationship. And what we see is, and this is done using the Human Connectome project data. When we did this, around 1,000 subjects data was available. Now it's 1,200. That in the last 6 or 1 year, more subjects have been added. So using this data, and this comes in handy, right? Because these deep network models require a huge amount of data. I mean, you could not have done this on 20 subjects or 30 subjects, which was the norm, say 5-6 years ago. The 1,000 subject is recent release that enabled this formulation of this. And what you see is that the model that we built has a better correlation with the ground truth compared to other competing models. And not only in the performance, but also in the actual connectivity patterns. This is the connectivity pattern that you obtain in this graph neural network simulation that resembles qualitatively the ground truth better than the other competing models. So what I have shown is 3 case studies that are primarily possible because somebody has put a large amount of data. And so what I say is that, of course, there are challenges, that neuroimaging data is complex, noisy, so the methods have to be robust, take into account. And there are ethical and privacy concerns in data sharing. The community is trying to address this. And currently, longitudinal data is still sparse. And of course, the newer methods which are scalable that take into account, imagine that this 1,000 subject data is imaging data. This is a huge complex and voluminous data that you require infrastructure as well as algorithms that are able to manage this sort of size. So lastly, what I say is that the big opportunity is especially sitting here in India, where you have your big toolkit with all the techniques. This is a data mining toolkit, this is a deep learning toolkit, this is a machine learning. And you are looking for a nail to hammer. And this is a very good nail to hammer. So there are, of course, what I suggest is don't just take the hammer and nail everything that comes your way, but go with a question. For example, one of the questions that we asked, what declines due to aging? What is resilient to aging? So formulate the question, and this question comes from domain knowledge. So you have to invest some time in understanding brain structure, function, and cognitive function, what types of function, right? So, and once you have that, there is enough data that is available. And I say in this particular area, data is ahead of theory. It's actually, there is a lot of data. It's crying out for a theory to make this sense out of this data. And so that's a great opportunity for researchers, right? So methodological innovation, for proposing new theories and testing them out within this. And also that, yeah, so the idea is finally that this contributes to not just applying a method, but we get insights about how information is organized in the brain. I said this is a big question. It's open. Right now, we don't even have a complete idea of how visual processing happens. We have fairly better idea, but there's still a lot of open questions in every domain that deals with the brain and cognition. Right, so that's the last slide, just summarizing what I've talked about, given you a glimpse of what is cognitive neuroscience and what are some of the data sets that are available. Gave you a case study of how you can exploit these data sets, 3 directions that I've given. By no means exhaustive. There are many other studies. It's an exploding area. There are a lot of papers coming out. Of course, we have to keep these challenges in mind when we are dealing with this domain. I only talked about complexity of the data, but the other challenge that is the domain knowledge, right? So this is not just any good old ML fitting or DL fitting exercise. This should give you some insight about how information is organized in the brain, and that we are better off because of this study. We are one step further in the understanding of brain and cognition. Thank you.
That was a very, very good presentation. I learned something. Thank you. Are there any questions? I want to go to you first. Yes, please.
Yeah, I'm Shobhan Kumar from IIT Dharwad. I have a couple of questions for you. Somewhere in your presentation, you said that inter and intra variability matters while looking at the image and how do you interpret. Does that geographical moment also makes an impact in that? For example, if I look at the image by sitting here and if I go out and sitting inside the park with a pleasant environment, does it make an impact?
Yeah, there is within, it does, I mean, or at least, let me give a more detailed answer than just saying yes or no. I would say yes, but yes, it does matter. There is a movement within cognitive science and cognitive psychology of using more naturalistic stimuli. So instead of pared down version, right, the typical psycholinguistic study or a cognitive psychology study creates stimuli because you have some experimental issues that come in if there are too many things varying. You don't know what this activation that you see, is it because of change in this dimension or that dimension? So you want to control, you want to randomize all the other things that are varying and control only 2 of them. For example, grammar, only grammatical, grammaticality of the sentence is controlled. Now you see, is the grammar violation, what kind of things you control for length of the sentence, the syllable length, and so many things that are controlled. And there is another school that says, okay, this picture is very limited. This is because these are well-tailored stimuli. So what you are understanding from this is limited to how these stimuli are. You should use natural conditions. So let them read or listen to a. So that is the idea of these 2 data sets that have come. There is no task. They are listening to a story. But as you can imagine that there are good and bad things in both. This is, you have very clear what this activation is relating to. Here in a freewheeling study with a naturalistic stimulus, you have to do, your methodology has to be different. The questions that you ask have to be different, right? But the field is equally divided. There is good on both sides, right?
Thank you.
Thank you very much. I am Professor Uday from University of Tokyo. I am also alumni of this college. I am proud of. So first, if you see the literature in the olden days, okay, in database or AI and all, first concepts emerge, okay, and we try to store the real world data using those concepts, okay. But in the recently, okay, there is a completely different. Okay, data miners or AI experts introduce models, and people are trying to bring their data, fit the data into some machine learning library, and saying this is the result, and this is the idea of knowledge. Okay, so there are billions of applications and trillions of interpretations from each person to person. Okay, now if we think like data can driven the theory, okay. Now my philosophical question is, which is higher, the stars in the sky or the data sets the humans are creating? Okay, because if we cannot understand this philosophical question, then we keep doing the same thing, like old wine in the new bottle. The mathematical pipeline remains the same, only change the data at the other side. Okay, so what do
Right,
you
so
think?
I'll take that as a suggestion for everyone, so we can move to the next question. Thank you for raising that point. Yeah.
Thank you, sir, for the wonderful session. And his question, actually, you have answered in your talk. You have said, just don't hit the nail and take the data and do something, frame a question and then address. So
Right, right.
it was like, my question was, I'm a professor in Cochin University of Science and Technology, and we are working on this effective neuroscience, how brain emotion models are working. So looking at that, like when you were talking about the structure and function relation about the brain, I just wanted your opinion on this Neuralink company, as Elon Musk company has come out with a brain computer interface. And they say that they have this tiny chips that can be implantable. And so they say that it is possible to regenerate the lost sections of the brain and then it works. And so I just wanted your opinion on that, sir. How far that it's a breakthrough.
So this implant, what does it do? Actually, I'm not familiar.
Yes, sir. They claim that it's they have this Neuralink has this human computer interface products that they have. They say it's this high density array chips are framed using this to simulate the brain structure, and this can be implantable, it seems. And it is already the MVP is out, and then in a year he is planning to actually demonstrate with the humans. And they claim that it is possible to regenerate this, this lost sessions of the brain due to accident or some even
So,
stroke
yeah.
and so on.
So there are two things. One is, the regeneration is a great process. There's a brain stimulation for rehabilitation is now clinically people are using. They put a magnetic coil on top of the brain. This is called transcranial magnetic stimulation or direct current stimulation. They stimulate an area that saw an insult, and they are seeing therapeutic uses of that. A low DC current stimulation or AC current stimulation can have a facilitatory effect in stroke patients, and these are non-invasive. This is not implant based. A more general question which should be asked is, where are we in terms of being able to decode activity, brain activity, either from EEG. For BCI, what is important is the machine should understand what the person is thinking. I would say we are at the rock bottom. I mean, you don't have to believe any hype. I mean, you have a fixed vocabulary. Yes, I can. The activity in some area tells me which of the 6 but you make it 12, it will fail. Which of the 6 states the brain is in? I can figure that out from the high density EEG or functional MRI. These things work in a decoding, works in a very limited domain. Right now, it is just scratching the surface. So it is a long time before anything that is useful that we can get. But already these may be useful for people with disability, right? They may want to move their wheelchair, right, left, forward, back, stop, 5. And if I'm able to decode that from the motor cortex, I have a device that is immensely helpful, right? In that sense, it is useful, but the general, I'm able to read your brain. That's a
Okay,
good
sir. Thank you.
science
Thank you.
fiction.
Thank you. Sir.
So now, thank you. This inventory talk is completed. Now we are going to have a 3 paper presentation. One of the paper cannot be. We are going to have 2 paper presentations. It is going to be chaired by Dr. Mamata. She has completed a PhD in Hyderabad, IIIT Hyderabad. I request her to chair the presentation.
Thank you, sir, for this opportunity. We have 3 papers in this session. The first paper title is HUI to WEC, Learning Transactions Embedding Through High Utility Item Set by Khalid, Philippe Fourier, and Jisam Javedi. Thank you.
Hello, everybody. Yeah, it's working. Hello, everybody. Thank you for accepting our research. Everybody's hearing me? Are you hearing me? Yes. Okay. Perfect. So thank you for accepting our research. Thank you for letting us present our work here at your conference. This is a very nice opportunity for us to exchange and to share with you the work that we have done. So I'm going to share my screen. I'm not sure if it's gonna. I think I don't have the right to share my screen. Please accept. It's saying that it's not possible for me to share my screen in order to share the presentation.
Hello, sir.
Hello.
It would be better if you can speak a little louder.
Okay. I just
You can share your screen, sir.
I can. It's not possible actually for me. When I try to share my screen, it's saying that it has been unauthorized.
He's allowing to share your screen.
Thank you. Thank you very much.
Yeah. So you can try, sir. You can share your screen now.
Okay. Perfect. I think that's it, huh? The screen, all the screen. It's okay, no?
Yeah, we can see your screen, sir. You can
Oh,
enter into presentation mode.
Okay, thank you very much. So, thank you again for accepting for accepting our paper, our research work. Thank you for letting us. Sorry, but. Yes, So this work, for letting us present our work, this is a very nice opportunity for us. Thank you very much again. So this work has been, it's called HUI to VEC. So this is for learning transaction embedding through high utility item sets. So this work is a collaboration between the University of Carthage in Tunisia and the University of Shenzhen in China. So this is made by my student, master student, Jassim Jawadi. Under my direction, I'm an assistant professor in computer science and robotics at Carthage University, and with the collaboration of Dr. and Professor Philippe Fournier-Vigier from the University of Shenzhen in China. So I'm going to start, the plan of the presentation is as follows. I'm going to start with the introduction, then the related work, and then explain a little bit more our approach. I'll give some experimental results, and we'll conclude with some of the future work that we are planning on to do. So the introduction, I'll talk quickly about frequent item sets, high utility item sets, and the embedding methods that can be used here to enhance actually the quality of representing a better way for representing the data. So transaction classification and clustering are very common data mining problems that have many applications in today's businesses, mainly in supported decision-making process. When they are applied for the use case of supermarket transaction data set, for example, these methods will support the decision-making with an enhanced and insightful customer profiling, for example, and a more accurate also and informative market basket analysis. This type of problems have been well studied in the literature, and many different methods have been proposed. Most of them can be carried out with machine learning techniques, such as, could be K-means, SVM, stuff like that. So here we understand that there is like a transformation step that is necessary here. We commonly refer to it as a feature abstraction. This is a mechanism very, very commonly used in machine learning and consists of transforming the data, the raw data that we have, into numerical features that can be processed in a better way and used in a better way by machine learning techniques. And for sure, they yield to better results than applying machine learning directly on the raw data. To generate useful features from transaction for transaction data, so like we said, it's on transactions here. A promising approach is to use frequent item sets. This is as features. A frequent item set is set of values that frequently appears in transactions. In real life transactions, data contain additional informations that are more explicative to data, that can give us more information about these data. For example, item sets that are more profitable than rather than frequent. Frequent item set mining, which is FIM, there, was generalized as high utility item set mining. The aim is to discover item sets that have high utility importance in transaction, not only frequent. They are more appropriate, let's say, than for a wide range of applications such as market basket analysis, clickstream analysis, biomedicine, cross-marketing, and so on. Mobile commerce also. Let's get back to frequent item sets. Here, more effective approaches have been proposed and introduce discriminative measures to handle the problem of high dimensionality and data sparsity that are faced with when using this type of, when using frequent item sets. They help extract only significant frequent item sets, but makes the feature extraction process supervised. These supervised FI-based approaches rely on availability and labeled data. However, labels are not always present and provided for our data. This is why it's we need another way of doing it. To cope with this type of limitation, Trust2Vec, which is by NBN and all at 2018, was proposed as a new unsupervised embedding method for learning low-dimensional representations of transactions. It's inspired, of course, we understand that directly from the name, that's inspired from embedding methods widely used in machine learning, mainly in text and natural language processing. Again, so we talked about frequent item sets, we talked about high utility item sets, and also about the way of using embedding in order to enhance and apply make it possible to use these embedding methods for non-labeled data. To our knowledge, there are still no studies that have attempted to benefit from high utility item set to create better transactions embedding than what was made with frequent item sets. In this paper, we present actually we present a method to learn transaction embedding through high utility item sets. So HashUI2Vec, which extends actually Trust2Vec, that operates more on the level of frequent item sets. Three main contributions of our work. So is an unsupervised method to learn low dimensional continuous representations of transactional data. Two models, we presented two models for it. So we learned transaction embedding from information of both singletons items and frequent and high utility items. And we demonstrate that HashUI2Vec is useful in transaction classification and achieves better results, let's say, than Trust2Vec on several data sets. So this is about the introduction. For the related work, we'll talk a bit about the two fields to which our method, new approach is related. So the first one is high utility item set mining, and the second one is vector embedding. So traditional approaches to high utility item set mining, HashUI-MR, they are actually decomposed in two phases. So the first phase, a set of candidate high utility item sets is generated by overestimating the utility. And the second phase, the database is scanned to calculate the exact utilities of candidates and filter out utility for low utility item sets. Many algorithms in the literature follow these two-phase approach. Recent algorithms will try actually to mine high utility item sets in the single phase. And despite these improvements, they still suffer from expensive. They still suffer. They're still actually very expensive in time and memory consumption. EFIM, Sida et al. 2017, is for efficient high utility item set mining, is a new phase algorithm that has been proposed and that introduced three major improvements. The first one is to introduce two efficient techniques to reduce the cost of database scans named high utility database projection and high utility transaction merging, HTM. Second, it introduced two new upper bounds on the utility of item sets. And finally, a novel array-based utility counting technique named fast utility counting, FAC, was used to calculate the upper bounds in linear time and space. FAM was demonstrated to be always perform better than other algorithms, both in execution time and memory. This is why actually we choose this algorithm inside our hash UI two-back approach. Our approach also is related to vector embedding methods. These are learned representation of the data in form of numerical values again. The performance of machine learning crucially depends on the quality of these vector representations.
Sorry
yeah.
for interruption.
Yeah,
you
sorry.
have more 8 minutes, so I would request you to wind up in next 10 minutes.
Okay, thank you.
Please be
Okay. Yeah, okay. I'll try. Thank you. Among them, so like we all know, I think word2vec is a well-known adaptation to learn embedding vectors for words in text. It is inspired approach to learn documents in text and approach to learn node embedding. Many others recent approaches are extending vector embedded to learn graph representations like node2vec, graph2vec, ripple2vec. These are works from 2020, 2022. Trans2vec again is an adaptation of vector embedding to learn transaction embedding. Is fully unsupervised and learns a transaction embedding from both item sets and frequent item sets. And the hash UI2vec would extend Trans2vec to learn transaction embedding not only from, not based on the frequency, but more on the high utility of the item sets. So now in this section, we'll go deeper inside the differential, our approach. So I will try to explain a bit quickly the problem definition. So we are given a set of items and a data set, a set of transactions. And the goal is to learn a mapping function here. So function f from D to R, D, which is actually the link between the transaction and the item set. So that every transaction is mapped to a function of Ti, which is a D-dimensional continuous vector. So these are this table is for the transaction. We have, let's say here we have 5 transactions in set transaction, and we have the external utility for each of the items inside the transactions. How we measure the utility? So utility of an item inside the transaction T2, for example, the utility of A inside T2 is A is here. So we have only the transaction 2, we have 2 times the item A, which has a profit of 5. So 2 multiplied by 5 is equal to 10. The utility of an item set AC is going to be U of A plus U of C. This is going to be U of A inside T1, U of A in T2, T3, and so on. And the same thing for AC. And it will give us this value here, for example. So here, instead of representing the item sets, we are going to present item sets using the utility. So here, high utility item set for minimum utility a factor that is set by the user or by the expert of the domain. We say, for example, the minimum utility is equal to 30. So this is all the item sets that have minimum utility of 30, for example. And we have another we are going to represent differently our transactions. So T1 won't have any high utility item set inside. More than 30, whereas T2 will have X2, for example, which is this one here, AC1. So this is like another representation. Each transaction is represented by a set of high utility item sets inside. Our problem definition, here I will just give the function, objective function, our objective function here. So this is the function f of our transactions here, contained on the transaction TFT. So here, this whole formulation here, we use 3 different we follow the negative sampling technique inside that we have in Word2Vec inside this equation, and this equation also is inspired by formulas that are defined in Trans2Vec. I think I don't have to enough time to go deep inside explaining this type of and this formulation. And the executive function also is minimized within the SGD. So already said that before that we implemented two models of our approach. So the first one is F of T. Each set we can face. Yeah, the first one is we are learning. We combine the operation for both items and high utility items to learn embedding vectors for transactions. This is for the first one. So we do we learn from the items. This is F1. Then we learn from high utility items to the stage from high utility items, and we do the average between the two. So we call that individual training model. And the second one, we learn both from information from items from high utility items are combined here, and we have our embedded vector from both of them here. And we call that joint training model to learn transaction embedding. This is very similar to the work that has been done inside Trans2Vec. And for the experimental results, so I'll start with talking a bit about the data sets that we used. So we used 4 data sets, all coming from the SPMF. So this is a very known data mining library implemented and by Mr. Philippe Fournier-Viger and his team at Shenzhen University. So we have 4 data sets. So Food Mart Utility, which is data set of customer transaction from a retail store. So from an SQL server. A chain store utility data set for customer transaction for a major grocery store chain in California. E-commerce retail utility with no time steps. The transaction recorded between for the years 2010 and the years 2011 on a UK-based online retail store. And Liquor 11, which is a data set of customer transaction from the US liquor stores from the state of Iowa. And our experimental results, we noticed that on overall, our experiments show that good classification proposed was achieved using our proposed method, HashUI2Vec, to learn transaction embedding from high utility item sets and item sets. 2 main observations are made here. So the first, we can see that the 2 models, of course, are clearly providing better classification on all data sets compared to the 2 other models from Trans2Vec. So this is joint, and this is for the joint training and individual training models. And the joint improved the accuracy over Trans2Vec joint. HashUI2Vec joint improved the accuracy if we compare it to Trans2Vec joint also. And all the data sets by a large margin. So that the proposal of incorporating information of both singletons items and high utility items is a better strategy than learning directly from only transaction embeddings and frequent item sets. Second, we found that HashUI2Vec joint produced better results than HashUI2Vec on all data sets, for the idea that transaction embedding learned from items and high utility items simultaneously are more meaningful and symmetric than learning from doing the mean, like we said in the first possibility. As conclusion, we presented HashUI2Vec. So we explained that we have implemented 2 models and that we have many improvements. And as an extension to our work, we plan on studying the impact of parameters on the method and our method more, and on using this extension to investigate the quality of embeddings for the transaction clustering task. And also we are planning on applying that for the SQL and for the sequence representations also. thank you again for letting us present our paper, and please, if you do have some questions.
Yeah, thank you for your presentation. You may stop sharing your screen now.
Okay.
It's open for questions. Questions, please. Okay, so there are no questions. Thank you for your presentation, Khalid. They will
Thank you very
reach you
much.
offline through email if there are any. Okay, thank you.
Thank you very much.
So the next paper is Discovering Top K Periodic Patterns in Temporal Databases by Likitha Palla, Udaikiran Ragi, Penigonda Ravikumar, and Yukta from the University of Aizu. The talk will be presented by Penigonda Ravikumar. Please welcome.
Thank you, madam. So, good morning, everyone. I am Penigonda Ravikumar. I am pursuing my PhD in University of Aizu, Japan, under the esteemed guidance of Professor Rage Udaikiran. So today, here is my presentation. So of course, this is the outline of my presentation. First of all, I would like to introduce my model. So and then I will show the limitations. What are the limitations in the existing model? And then I will propose my model. And then I will show the experimental results of my ongoing work. And then finally, I will conclude that. So coming to introduction. So first of all, I would like to introduce what is a temporal database. So temporal database is nothing but a collection of ordered set of transactions. So for example, if you consider supermarket database, so there you can have some of the items like bread, jam, butter, milk, like that. So for example, at 9 a.m. in the morning, a person may purchase bread and milk. So we will record that information. So here we are going to record both the temporal information as well as the set of transactions which we have purchased. So at 1 p.m. he may purchase some other items, books and pens, and at 7 p.m. he may purchase different items, and at 8 p.m. we may purchase different items. So this is nothing but a sequence of set of transactions. This is nothing but a sales database. We call this one as a temporal database. So here we are recording timestamp information along with the set of transactions which they have purchased. So for example, if you generalize this database into a generalized version, so we can get the database like this. So of course, we are using this table inside our paper for representation purpose. So here we have taken 10 transactions, so which were happened at a particular timestamp information. So at timestamp 1, these are the items which we have purchased, something like that. So of course, so our intention is that in the supermarket, customers may purchase different items, but at what time, what kind of items were purchased? So that is our useful information hidden inside the databases. So that is our objective, to collect that information from the database. So coming to periodic frequent patterns, so we are identifying the periodicity of the items which we have purchased. So of course, here we have taken a database that is for a representation purpose. So this is the congestion database. So we have collected from Japanese region. So this is the congestion database. That means here at time instance 0 at road number 1. So what is the congestion length? So that we are going to collect it. So this is the actual, these are the sensors. These are different locations of the sensors which were placed in the Japan road traffic. So here we are collecting the congestion information. Of course, after collecting the congestion, we are going to group the information at time instant 1. What are the roads which are having high amount of congestion? So we have transformed that one into a temporal database, and then we are going to apply our periodic frequent pattern mining model to extract how regularly and frequently congestion is happening at a different set of road segments. So, and then at the we have evaluated our congestion database along with some kind of other data, that is typhoon Nangaka. So some kind of typhoon has happened at that time. I mean, some kind of disaster is happening at that time. So if you give some information to the traffic people, like, so, okay, there are some congestion is happening and in that area, rainfall is very high. You may redirect the traffic values. So that is the application of our model. So that we are proposing that. So of course here, so we are going to extract periodic frequent patterns with the help of two constraints, that is the minimum support as well as the maximum periodicity. So from minimum support, we are going to extract how frequently items are dragged, and then from maximum periodicity, how regularly we are going to extract the items from the database. So with the help of these two constraints, we are going to extract the periodic frequent patterns. So for currently in the existing models, we are going to use these two constraints, that is minimum support and maximum periodicity. So this is a basic limitation because a naive user may don't know about what is the minimum support and what is the maximum periodicity, how much amount of minimum periodicity and maximum support should be given. So that is why so the current studies has moved to top K periodic frequent patterns. There we are not giving any minimum constraints like any constraints like minimum support and maximum periodicity. There we are going to use only K is the constraint for that. So that we are going to extract periodic frequent patterns with the help of just a single measure, that is constraint measure, that is top K. Okay, so of course this is some kind of limitation in the existing model also. Of course we have extracted top K patterns in the existing model. But the thing is, in the existing model, they have considered only frequency and they have completely ignored the periodicity of the extracting patterns. So that is why we are going to propose our new model. So our contribution is, we have proposed a novel model with the help of depth first search based algorithm. And then we have extracted top K periodic frequent patterns with the help of just K parameter. We have used only single parameter K. With this, we are going to extract top 5 or top 10, top 100, top 200 periodic frequent patterns. So that is our ultimate goal. So here we have proposed a novel dynamic maximum periodicity constraint. Of course, this is also inbuilt inside the algorithm itself, and then the user need not to give any value to this. And then we have experimented our algorithm against synthetic and real world databases. So our algorithm is very well. So coming to proposed model, here I would like to say that first of all, what is the temporal database? So here we have considered O is nothing but a collection of all the items, and then T is nothing but a transaction. Here transaction is a two tuple, that is timestamp along with what are the list of items which are present in the transaction. This is the collection of transactions, is nothing but our temporal database. For example, here we have considered 5 items PQRST. Okay, so based on this, we have created a sample temporal database with the help of 10 transactions. So here first item is the timestamp information, and then this is the number of items which are present at that particular timestamp information. So here we have considered 10 samples. Of course, we are going to extract, we are going to identify, okay, a sample pattern, that is PR I am using. So here PR, I am going to identify whether PR is a periodic frequent pattern or not. Okay, so for that, to identify PR is a periodic frequent pattern or not, so we have identified the timestamp information of that particular pattern. So PR has appeared at 1, 3, 4, 6, 7, 8, and 9 transactions. So here we have calculated the periodicity as follows. The initial periodicity we have given it as 1, and then final periodicity we have given it as 10. So the pattern PR has appeared like this 1, 3. So we are going to evaluate the inter-arrival time between the transactions. So here the interval time, first interval time is 0, 1 minus 0 is 0, and then 3 minus 1 is 2, 4 minus 3 is 1. So like that we have calculated the periods of pattern PR. Out of this, we have identified the maximum period is nothing but the periodicity of that particular pattern PR. So here PR maximum periodicity is 2. So because the maximum period is 2, so here we have received maximum periodicity is 2 for PR. So if we assume that the maximum periodicity is greater than 2, then we can say that that element is our periodic frequent pattern. So here we, instead of maximum periodicity, we have taken dynamic maximum periodicity. So here we have used some variable EPK. So with each is considering our only candidate periodic frequent pattern. So for example, how I will calculate, I will show you now. So I am going to extract top 5 periodic frequent patterns from our 10 sample temporal database. So here, first of all, I would like to extract the one length items. So these are R, P, Q, and ST. So their periods we have calculated it as like this. In the previous slide, I have shown you. So out of these periods, which is having the maximum value. So 4 is the maximum value. So then I am assuming that our dynamic maximum periodicity value as 4. Sorry. So this is the dynamic maximum periodicity value for the current patterns. So if the periodicity is less than this, then we can say that all those items are periodic frequent patterns. So of course, here every element is less than this dynamic maximum periodicity. So we can say that R, P, Q, and ST are now periodic frequent patterns. So accordingly, so if we choose one more item like, so now I would like to calculate from one length patterns, I would like to calculate whether the next element is in the depth first search manner. So the next element is R, and then next element is RP. So now I would like to identify whether RP is a periodic frequent pattern or not. So for that, I have again calculated the periods of all the values, and I would like to replace the element which is having maximum periodicity. Here, T is having the maximum periodicity is 4. So I would like to replace that with the superior, that is RP. So now I would like to replace that. And then now I would like to calculate again the dynamic maximum periodicity value. So now the dynamic maximum periodicity value is, the maximum one is 3. So that is I have calculated now. So now the periodicity is inbuilt inside the algorithm itself. We are not going to give anything from the user end. So that is our intention. So similarly, we can calculate for RPQ also. So if you follow that, so the maximum periodicity is having now at present, S is having the maximum periodicity. We would like to replace it with the next item RPQ. So I have replaced it like that. So now current dynamic maximum periodicity, out of this, we are going to identify the maximum element. So again, the dynamic maximum periodicity value updated with 2. So like this, if you follow in the depth first search manner, we can extract all the periodic frequent patterns for like this. I have represented all the non-striking elements as our top K periodic frequent patterns. So initially I have identified R as our periodic frequent pattern, next RP as our periodic frequent pattern, next I have identified RPQ as a next element, and then I have crossed out RPQS because which is not satisfying our dynamic maximum periodicity constraint. So I have moved down. I have crossed out. So like this, we can extract all the top K periodic frequent patterns. So coming to experimental results, we have executed our algorithm in this server mission using the Python language. So and I have experimented against 5 real world and synthetic databases. So this is the statistics of these databases, these real world databases, and then synthetic database. So you can see that information inside the paper. So of course, in the experimentation, we have evaluated what is the runtime amount. Okay, how much amount of time it is taking to extract the top K periodic frequent patterns. I have represented here, and then how much amount of memory has been consumed by the program while calculating the top K periodic frequent patterns. I have shown that against this figure. So in every database, we can show that while increasing the top K value, number of periodic frequent patterns are also increasing. That is why runtime is in increasing order and memory is also in the increasing order. In every figure, we can observe that. So of course, this is our first algorithm. So that is why we have not compared it with any existing models. There is no existing one. And then we have executed our model, evaluated our model with the help of scalability. Like we have taken very big database and have executed and extracted patterns there. So that is why this is taking huge amount of time. So of course, the database size is around 10 lakhs. So okay, even the 10 lakhs data transactions also, we can get the patterns very easily with the help of our algorithm. And then we have shown our algorithms runtime and memory here. So coming to conclusion and future work. So I would like to conclude that we have proposed a novel top K periodic frequent pattern mining method. And then we have proposed a novel pruning method also. So that is dynamic maximum periodicity as part of future work. So we would like to work on the uncertain databases. We'd like to extract top K periodic frequent patterns in uncertain databases. So thank you very much for the opportunity.
Thank you, Ravi. That's a very good presentation and very good work. Floor is open for the questions, please. If nobody is having a question, then I could ask.
Yes.
Can we apply it to any other city or just Japan?
Yeah, we can apply to any city, man, no issue, because we need to have the database, that's it. So at present, we have the database of Japan, so that is why we have used that. So if you have Hyderabad's database also, congestion database,
So
we
you
can
need
apply.
geographical information of that particular city.
And then we
Then
can
you can
apply our
apply.
algorithm. No
Okay,
issue.
thank you for your presentation.
Thank you.
So what are the patterns you're trying to find out? Are they going to be same for the period of time, let's say? So if there is uncertainty is happening, so the pattern may change. Are you going to find out such things, or you're involving such things into the thing?
No.
Because the traffic is depending on, the congestion is depending on the situation which is around the thing.
Yeah.
Let's say the conference is happening here. At the signal outside, you can see in the evening, there will be congestion, more congestion.
Yeah, that's what. So here the database which you have collected it in on 2016, and then during particular time in 2016, from this time to around 1 month, we have collected the information. So if you give the traffic data now itself, so then if you give the landline readily, if you give the database, so I mean currently you are saying that traffic is going out. So if you give the database, we can apply it, no problem. Okay, but this in the paper we have presented the data of 2016. Yeah.
I will try to continue this question. No, what is his name? Yeah, Monacharya, I am also the co-author. Yeah, your point is valid. So the work that Mr. Ravi is doing is completely finding full periodical occurring patterns. Means I give the data set, you find all the patterns that are appearing regularly throughout the data set. Okay, but your question is very valid. That is, if the pattern stopped in between and it appeared again. So they are not called periodic, they are called reoccurring patterns. No, they're not outliers. Like in the morning, you will find traffic jam. Afternoon, you don't find traffic jam. Evening, again, you find the traffic jam. So there is a seasonal behavior that is happening. So we can call it concept drift. Okay. So if you observe the drift of the pattern's behavior, we call them reoccurring. Means they appear in the morning, they appear again in the maybe in the evening, then again they will reappear. Midnight, they don't appear. Right. So they are called reoccurring patterns. So we have some work there, but in this paper, he focused only on full periodic patterns. Okay, is my answer sufficient? Thank you.
Any more questions? Okay, fine.
Thank you.
Thank you.
So we are, the morning session is over. So now we have a tutorial 2, supposed to be tutorial 2 by Raghav. Just a minute, there's a change actually, I have to announce. Due to health emergency, we cannot have tutorial 2. So instead of tutorial 2, we requested tutorial 4 presenter to present instead of tutorial 2. So next tutorial will be by Mayuri Mehta, title Self-Supervised Learning for Process Labeled and Unlabeled Medical Image Data. So the sudden health emergency occurred to the speaker, so we cannot have. So that is the tutorial 2. After that, we'll have a panel. Okay. Now we are closing now. So please move for lunch. After that, come back at exactly at 1:30. Okay, 1:30, 1 hour. Please come back at 1:30. So we are going to start. Thank you. Thank you.
what we want to build here. So first, we want to understand the current security environment and challenges, and then we want to build next generation.
Hello, welcome to afternoon session. We'll have a tutorial. After 3 minutes, we are going to start. Thank you. Hello, good afternoon. Welcome to the VDA 2022 conference. On third day, first is workshop, Second day the conference, this is the third day conference. We are starting the afternoon session. So the tutorial supposed to be delivered by Raghav Mutturaju would not be delivered because of sudden health emergency for the author. So we have requested the presenter of tutorial 4, Dr. Mayuri Mehta, to present in this slot. So she has accepted, and I thank her for accepting to make a presentation now. Now I request Professor Avinash Sharma, IIIT Hyderabad, to chair the session and introduce Dr. Mayuri Mehta. Thank you.
So good afternoon, everyone. I hope all of you had a good lunch. I happen to be also chair of the mess committee here. So if you have any feedback, well, now I'm no more. I'm still a member of the committee. I hope it's not be too much of, yeah. So I hope it won't induce too much sleep into you, because post-lunch sessions, especially classes, are definitely sleepy for any human being. So you will not blame. So I'm from computer vision domain. I did my master's at IIIT itself, my PhD at INRIA in Grenoble, in south of France. And then I was briefly at Max Planck for postdoc, but then for personal commitment, I came back, spent a couple of years in Xerox Research Center in Bangalore, XRCI. And then I decided to move back to academia as an assistant professor at IIIT. And since then I'm here, and I'm doing largely on, so I'm not into too much of medical domain, but yeah, I'm from the domain. I have taught image processing, and I have also worked on a little bit cognitive science and this kind of areas. But my primary domain is in 3D computer vision. So anyway, welcome you all. And I think the focus should be on the speaker now. So I would like to welcome Dr. Mayuri Mehta, who is a speaker for today's session. She is a faculty professor at Sarvajanik College of Engineering in Surat. She did her PhD from NIT Surat. And she has a lot of accomplishment into her, what she has achieved. So she's largely working on the healthcare informatics, applying the AI for healthcare products, while of course teaching those things. So she has around 11 patents that she's holding right now, 1 copyright, 33 plus publications, and 3 books. I think 2 books she has already published, and 1 book will be published on explainability of AI. And then she has been to multiple countries for collaboration, attending many other conferences. She has also earned this award of Researcher of the Year award by IBAE in 2021. And she is working with a lot of practical impact that she's trying to make by taking the AI solutions to local doctors, to municipal corporations there. And she has earned funding from them, support from them, to really mitigate that gap that exists between the academic research and deployment on the field, where the major challenges lie. So with this kind of accomplished, experienced biography, I would like to invite her to deliver a talk on this tutorial on self-supervised learning to process medical image data. So welcome, Dr. Mayuri. And if you guys have any question, I think we can decide a protocol. Either you can raise a hand and ask immediately, or we'll have a question answer session. Whatever speaker likes, we can go with that. Sure. Okay. Okay, so enjoy the session, and just clap once for the speaker. Take the podium.
Thank you so much for the nice introduction. A very good afternoon, everyone. And as Sir said, you had good lunch, and it's really a challenge for me to keep you all awake during this session. Okay. Firstly, I would like to thank Dr. P. Krishna Reddy and BDA team for inviting me and allowing me to share my views on self-supervised learning to process medical image data. And this is it's a pleasure to be here in the consecutively 4th time in BDA to conduct the tutorial. the information which I am going to share with you, that is either collected from web resources or it is from our own research work, and this contents are for informational and education purposes only. These are the learning objectives of this session. By the completion of this session, you will understand the significance of medical image analysis for in-depth but non-invasive exploration of internal anatomy for disease diagnosis. Then you will also be familiar with different methods to process unlabeled medical data. You will get insights on self-supervised learning to process medical image data. And you will also get exposure to a self-supervised learning-based use case in healthcare. This would be the flow of my presentation. I will first introduce medical image analysis briefly, because probably you might be aware of what is medical image analysis. After brief discussion of medical image analysis, I will discuss labeled and unlabeled medical image data and the different types of medical image modalities available. Then I will introduce self-supervised learning to process medical image data, though we have several machine learning techniques like supervised learning, unsupervised learning, semi-supervised learning. Then what is the significance of self-supervised learning? And finally, I will discuss one use case, which is self-supervised learning based in healthcare domain. Okay, we all know that today AI has proven beneficial in almost every real life sector, including healthcare. And it has proven like several benefits in every real life sector. So these are the various applications of artificial intelligence in healthcare, that it is used for drug discovery, it is used for treatment design, medication management, it is used for medical image analysis, it is used for healthcare system analysis, also for clinical decision recommendation, AI-assisted robotic surgery, and also for genetic and genomic-based research. So how this AI has evolved in healthcare, I would like to share with you. Today we have, the first reason is today we have an enormous amount of electronic health data. This enormous amount of electronic data doesn't make any sense until you transform it into knowledge. And to transform it into knowledge, we need rapid analytic techniques like natural language processing techniques and machine learning techniques. And we also need substantial additional computation power. So today we also have additional increased computation power since past many years. And we also have good analytic techniques. So due to this, it has been possible to carry out, like AI has evolved because we have rapid analytics techniques, we have increased computation power, and we have digital data. Earlier also we had healthcare data, but it was not available in digital form. So though AI techniques were there since 1950, we never applied them to healthcare data because healthcare data was not available in digital form. But today it is available in digital form, and that too in massive volume. So it has been possible to apply AI techniques. And because of that, several researchers from both sectors, medical and technical sectors, they are carrying out research in this domain. And because of this, all the big players, all the big companies like Microsoft, Google, IBM, Amazon, they are investing billions in AI-related healthcare domain. So AI-related job market is rapidly increasing in healthcare because of that. So among these several domains, medical image analysis, it is widely explored area for research. So let's see that what exactly the medical imaging is. So before we discuss medical image analysis, I would like to discuss what is medical imaging. So we know that how diagnosis is carried out clinically. These are the steps that how diagnosis is carried out clinically. This is medical diagnosis. So disease diagnosis is carried out following these three steps. Doctor collects information, disease-related information from patient via dialogue with patient. After that, physical examination is carried out to observe symptoms related to that disease. And that is followed by, if the patient is suspected to suffer from any disease, then patient is prescribed some medical tests. And those tests may be laboratory tests, they may be biosignal tests, or they may be image tests. So imaging tests, as we know, they are like different types of image modalities are there because different types of imaging tests are there. And these are the different types of medical image modalities. They are mainly categorized into two categories, radiology and visible light photography. And radiology is further divided into this subcategories, X-ray, CT scan, MRI, ultrasound, and so on. And this visible light photography, it is further divided into this microscopic image, dermoscopic image, endoscopic image. And here I have included one sample image of each type of this medical image modality. Right? So you can see that how microscopic images look. This is microscopic images. This is endoscopic view. This is dermoscopic images. So different types of medical image modalities are available. Now, even if you focus on any one type of medical image modality, several research opportunities are there. For example, we know that X-ray is used to diagnose bone-related diseases. It is also used to diagnose TB. It is also used to diagnose corona, pneumonia, etc. So even if you focus on one type of modalities, enormous research opportunities are there. For example, let's say ultrasound. So ultrasound is used to view and provide information related to some internal parts of the body like heart, blood vessels, then female reproductive system, abdomen, etc. So for example, here you can see that if we take abdomen ultrasound image, it includes information related to several parts, and these are the like major parts. There are also many small parts in our abdomen, but these are like stomach, small intestine, large intestine, liver, gallbladder. So if we analyze this abdomen ultrasound, then it may help us to diagnose gallstones, kidney stones, liver-related problems, if there are a cause of the stomach pain, etc. So when you focus on any kind of image modality, moreover, apart from this, there are also several unexplored and rarely occurring diseases which have never been researched. So you can also focus on those diseases. But the major challenge when you carry out research in medical domain is data, the quality, amount of data and the quality of data. We will discuss it later, but this is the major challenge we face in this domain. Okay, so now what medical image analysis? We have seen medical imaging and different types of medical image modalities. So what is medical image analysis? It is a process of extracting meaningful information from medical images to diagnose the disease or disease state, to diagnose the disease or to know the disease state. So that is medical image analysis. Now, usually it is carried out manually by doctors when patients go to clinics. Then what is the need of computer-aided medical image analysis? So first, I would like to tell you that what's the need of automated medical image analysis. These are the limitations of manual medical image analysis. The major limitations are this diagnosis varies from doctor to doctor due to varying expert knowledge, human errors, and other such factors. So when you go from one doctor to other doctor, there may be variation in diagnosis, and because of that, there may be different treatment. They may prescribe you different treatment. Second major disadvantage is that there is a possibility to lose the minute hidden pattern in medical image due to limitation of human eye, due to limitation of human eyes to view the macro data. And this macro data sometimes is very useful to diagnose accurate diagnosis of disease. So these are the major limitations of, there are other limitations too, but these are the major limitations due to which the computerized medical image analysis has come. Okay. Now, then what are the benefits of computer-aided medical image analysis? So benefits are, it improves the efficiency of the medical professionals in arriving at an unbiased and objective decision in a short span of time, because as I have told you, the manual disease diagnosis is subjective. So this brings objectivity in disease diagnosis. The second benefit is multiple modalities reveal information that is otherwise invisible to human eye. Nowadays, in automated disease diagnosis, the fusion of several images is also used. For example, in our one research, we fused two types of images, intraoperative CT and post-operative, like preoperative and intraoperative. So that way the fusion of medical images is also possible, and that reveals the information which helps a lot for accurate disease diagnosis. So multiple modalities can be used, and this additional information which is provided by fusion of medical image modalities can be utilized for more precise localization of abnormalities at early stage. And if diagnosis is carried out at early stage, it reduces the financial burden of the patient. It also reduces the spend to recover from that disease, etc. So this is required. Fine. So so when it is a computerized medical image analysis, it helps to perform this task. Computerized medical image analysis is usually used for visualization and exploration of 2D images and 3D images. It is also used for segmentation, classification, registration task, and it is also used for 3D reconstruction of image data. So these are the purposes of computerized medical image analysis. Okay, now this deep learning, it has been used in medical image analysis since almost 2012. So almost since 1 decade. And you can see that these graphs, they illustrate the statistics. That here you can see that in 2015-16, the use of deep learning increased in 2015-16. And this other graphs, this shows the use of deep learning for different tasks. As I told you, computerized medical image analysis, it is useful for this task. And this shows that how many papers are available for this different task using deep learning. This shows that they are using which image modality, medical image modality, and this shows that these papers are addressing, they are focusing which part of the human body. So a lot of research is going on, but you can see that still, like in medical image analysis using deep learning, the amount of work which has been carried out, it is comparatively less. Why is it so? Because as I told you, the major challenge is we don't have a good amount of data, and moreover, we don't have a good amount of quality and label data. So that is the major challenge. Okay, we can skip this. Fine. So this is example we discussed that this is used, like medical image analysis is used to diagnose several diseases. So this is an example. A group of Stanford University, they developed AI algorithm, and they tested that algorithm against 21 dermatologists, and they verify its ability to identify the skin cancer. And their experiments revealed that this algorithm developed by them, it was at par with the dermatologists. The performance was at par with the dermatologists. And the clinical findings demonstrated that artificial intelligence is capable of classifying skin cancer with a level of competence comparable to dermatologists. One more example I have included here. This is a Google AI algorithm, which analyzes the scan of back of the eye, and analyzing the scan of the back of the eye, it deduces the information like patient's gender, patient's blood pressure, patient's age, etc. And from this information, it tells us that what are the chances of cardiovascular risk for that patient. So these are like two examples, but there are many more examples you will find in literature that how medical analysis is, medical image analysis is useful. Okay, as we have discussed, nowadays, multiple modalities are also combined to reveal the macro information hidden, which otherwise invisible to human eye. So this information also helps for accurate analysis. And here you can see that the images can be fused, like you can fuse MRI with CT, and you can fuse CT with ultrasound, etc. So that is also possible. Okay, so far we have seen that what is medical image analysis and which are the different types of medical image modalities. Now, to create computerized disease diagnosis, we feed data to machine learning model, and we know that the data is the fundamental for machine learning model. And when we talk about the machine learning model, the two types of techniques come to our mind, and that is supervised learning and unsupervised learning. And we know that for supervised learning, we need labeled data, and for unsupervised learning, like unsupervised learning techniques, they process unlabeled data. So let us see the examples of labeled and unlabeled data in this medical imaging domain. Okay, labeled data. There are different ways to label the data. Manually, we can label the data, but that needs expertise, like domain knowledge is required to label the data. And there are other ways also, like internal labeling, synthetic labeling, programmatic labeling, outsourcing, crowdsourcing. Each technique has its own pros and cons, but there are several techniques to label the data. But data labeling, it is a time-consuming task. It requires domain knowledge, and it is subjective when it is labeled by different people. Suppose like set of data, a set of images, if you have given to one doctor, set of images you have given to different doctor, right? Then it is always subjective. So that is also problem. Moreover, when it is a huge amount of data, for deep learning models, we need a huge amount of data. So it is time consuming and cumbersome task. So though it has benefits, like disadvantages are also there. So this is the example of labeled data. We are working for this laparoscopic images. We are working in this to predict the next action during the surgery. Next action to be predicted, and this data set is available. This we got from MICAI challenge. We participated in MICAI challenge in 2020. And as we participated in that challenge, we got this data set from there. Other data set also we got. And this data set is labeled data set. This is the example of labeled data set. And this data set includes 160 images of laparoscopic surgery. And this images, like there are 16 actions. There are 16 actions which can be predicted. So for each action, it includes 10 images. So total 160 images are there, and it is known as surgical actions 160 data set. Now here you can see that which are the labels. These are the labels for these images. Like cutting action, and this is suction, noting, right? These are the actions. But then during research, we observed that if tool is also detected before detecting the action, like if tool, then tool can be mapped with action, because there are multiple actions performed by the same tool. There are multiple actions performed by the same tool, so tool also needs to be detected. Now here you can see that in this data set, tool is not labeled. Actions are given. But as I told you, the same tool, like if it is an image containing the tool, then that tool is performing two different types of actions. So sometimes misclassification happens because the same tool is performing two different types of actions. So for that, tool labeling is also required. So though sometimes labeled data set is available, it is not useful for our objectives, research objectives. And we need ways, we need techniques to label that medical image data. Okay. This is unlabeled data. This is also this is also from our research. We collected this data from orthopedic surgeon. In this research, we want to predict a point on femur. Femur bone is located here at this part. We have two femur bones and they are located at this part. So sometimes we call it hip fracture. So when surgeons have to fix that fracture, they have to first locate a point on femur from where they will insert the guide pin. And from there, they will insert the screw. So our task is to predict, because doctors have shared with us that if the surgeon has less experience, or if he or she is a new surgeon, then due to less experience, they may, by multiple attempts, they'll be able to locate the correct point. And that harms the patient, because multiple attempts are made to find the correct location of that entry point. So our task is to estimate the entry point to insert the guide pin in this research. So we collected fluoroscopy images from orthopedic surgeon. And here you can see that these are the images provided to us and they are not labeled. So it was a major task and challenge for us that how to label this data, because we don't have sufficient domain knowledge. So we asked that surgeon to label this data, but they are very busy in their daily jobs and they don't have time to label those many images. So then we checked that is there any tool available to annotate this data. So we found several tools to annotate this data, and these are the, like in this chronological order I have included them. These are the several tools which can be used to annotate data. But among them, some are licensed, some are open source. Moreover, some require scripting like programming, and some are very user friendly. So we checked with all the open source tools, and among them we have used Make Sense to label our data. Make Sense is very easy. Like I have kept that website open. At the end, if time permits, I'll show you that it's very user friendly. Just you have to upload the image. Then on the right hand side, some shapes are given: circle, square, polygon, dot, everything. So wherever you want to put, like you have to use that shape and you have to put it on the image, and then you have to specify that what exactly you want. So it generates annotations either in the form of CSV, XML, sometimes with metadata. So these are very good tools. So we annotate with Make Sense, and we got those annotated images verified from that orthopedic surgeon. But still, as I told you, that this is a very small amount of data which we collected from surgeon. And if we collect it from the different surgeons, it would be a huge amount of data, and we need to label it. So many of the times in medical field, when we carry out like automated disease diagnosis from medical image modality, the challenge is we have a small amount of labeled data and we have a huge amount of unlabeled data, and we have to work with it. Now, if we spend a lot of time in labeling that unlabeled data, that still challenges are there because it is subjective and it requires time. Sometimes we also need to spend money for that. So what's the way? So different ways are there to process that unlabeled data. Okay, this is the labels we have got for this images, our data. Okay, so there are ways to process this unlabeled data, and everyone knows that unsupervised learning is very popular to process unlabeled data, but it also has challenges, right? So unsupervised learning is there, but I'll show you the challenges or disadvantages of unsupervised learning. So when we do not use unsupervised learning, then which are the other ways? So these are the two popular ways: semi-supervised learning and self-supervised learning. Self-supervised learning was introduced in 2020 by Facebook AI chief scientist Jan LeCun. It was first introduced for NLP. It was heavily used for NLP, but now people have started using it for computer vision also. So many applications are available for NLP, but still like people are using it for computer vision also, and it's giving good results for computer vision applications also. So this is self-supervised learning. This both are semi-supervised learning and self-supervised learning. They both are hybrid learning approaches, but they are completely different, though they both are hybrid. Like semi-supervised learning, it is a combination of supervised and unsupervised learning. There we need labeled data, and using that labeled data, you might be knowing that again, it is working based on this concept, right? So we provide labeled data, it generates pseudo labels, and then it generates pseudo label, and that is used in next iteration, and that way it is working. But I'll not discuss in deep that how semi-supervised learning works, but that is semi-supervised learning. It needs human intervention. It needs label in the form of label data. It needs human intervention in the form of label data. Well, self-supervised learning, as its name specifies, it learns automatically. It does not require human intervention in the form of label data. We are using self-supervised learning for the problems in which we have a small set of label data and a large set of unlabeled data, but still we are not using that small set of label data to generate labels for unlabeled data. We ask model to learn. This is kind of autonomous supervised learning. We can say it is sometimes also called autonomous super learning, right? So and people also say that it is extended version of unsupervised learning, but like unsupervised learning, it does not cluster data into, it does not group data into clusters. So this is the difference between self-supervised learning, though it is called extended unsupervised learning. This is the difference between it and unsupervised learning. Okay, so here are the disadvantages of unsupervised learning and semi-supervised learning. like in unsupervised learning, as we don't have label, when we get output, there is no way to check its validity, its accuracy, that whether it is accurate or not, because there is no ground truth. So it's difficult to measure the accuracy of algorithm trained with unsupervised model, and it can have widely inaccurate results unless you have human intervention to validate the output variables. That is the disadvantage of unsupervised learning. The major disadvantages of semi-supervised learning are, they are also like outcomes of iterations are unstable, and we can't check, we can't verify their accuracy because we have a small set of label data. So we have this self-supervised learning to process this medical image data. So what is it? It is as I have told you, though it is a hybrid approach, but it is not like working as unsupervised or supervised learning. It is autonomous supervised learning. So through this, it uses like self-supervised learning. It automatically, uses the underlying structure of data. It learns the visual representation of data, and it generates supervisory signals from that data. Leveraging the underlying structure of the data, it generates supervisory signals. And this supervisory signals, they are used as ground truth in next iteration. All of them may not be used. The labels with high confidence will be used in next iteration, and that way it goes through several iterations, and finally we will have a model which has learned all the features of the from the unlabeled data. I'll show you with example that how it learns. Okay, so it is an intermediate between supervised and unsupervised learning, and it eliminates human intervention, which is there in semi-supervised learning in the form of label data. So while developing labels, it doesn't takes label data, and it itself learns from the data. It generates supervisory signals, and the major types of self-supervised learning are contrastive learning and this non-contrastive learning. Yes. Supervisory signals are generated using the pretext task. I'm going to discuss those pretext tasks. Yeah, it uses the difference, like similarity and dissimilarity is calculated. Here you can see that these are the learning. So whether it is correct or not, that supervisory signal is correct or not, that is verified with this. If it is contrastive learning, the distance is measured between those. So that I'm going to discuss with example. So here you can see that contrastive learning is to reduce the distance between positive data to the minimum, and to increase the distance between negative data to maximum. So this difference is calculated to check whether supervisory signal is correct or not. And non-contrastive learning means the domain is still largely unexplored, but it seems very promising. Less techniques are available in this domain. Yeah, so in past 2 years, as I told you, self-supervised learning was introduced in 2020, and like a lot of research is going on in this. Several frameworks have been proposed in literature, and it is categorized this way. Self-supervised feature representation learning can be carried out based on pretext task, or it can be carried out based on non-pretext task. I'll tell you what is pretext task. And this is further divided into contrastive representation learning and non-contrastive representation learning, and several subcategories are also there. So, but in brief, I can tell you that all these frameworks, they differ from each other with respect to number and type of pretext task used by them. Second, application domain. Third, backbone model they have used. And fourth, loss function they have used. So they differ with respect to mainly these 4 parameters: application domain, backbone model, loss function, and whether it is pretext task based or non-pretext task based. Okay. So due to limited time, it won't be possible to discuss all these frames, but I will. This is the fundamental framework for this self-supervised learning, SIM-CLR, simple contrastive learning. I will discuss it with examples so that later you can explore the remaining frameworks. Moreover, to understand this frameworks, you need a good knowledge of deep learning models and also neural networks. So then only you'll be able to understand this. These are the prerequisites to understand all the supervised learning frameworks. Okay. So these are the different pre-test tasks. Pre-test task is augmented task. It is augmented task. So these are the different types of pre-test tasks. You can see normalization, resize, rotate, relative positioning, colorization, jigsaw puzzle, Sobel filter. I'll briefly tell you the function of each of this operation. These are augmentation operations. The normalization, it is mainly used to ensure the pixel distribution of the input image. This resize, it is used to accelerate the training speed of the model, learning model. Then rotate, it is used like using rotate augmentation operation, different views of the input image are generated and features are learned from the different angles. Features are learned from this different views of the image. This is relative positioning. It is for spatial, it is to know the spatial representation of the different parts of the same image, like spatial representation of the same image. If you take the different patches from the same image, different parts from the same image, their spatial representation would be same. But if they are the parts from the different images, then their spatial representation would be different. So it is to learn that. The next is colorization, like colors are changed, and to learn the visual representation. It is simple. Jigsaw puzzle, we know like what happens in puzzle. Jigsaw puzzle, it divides the image into parts and it asks the model to learn that these are the different parts of the image, and it asks model to identify the sequence of those parts. And the next is Sobel filtering. It is to learn through, it is to learn the visual representation of image via extracting the edges from that different objects of the image. So that is, these are the different operations. So different, I'm sorry, it got disconnected. I'm using like Wi-Fi, yeah. Yeah. So, should I disconnect?
No, it will connect.
Okay, I should have. Should I?
Just rejoin the meeting. Rejoin the meeting. Password. Meeting ID in the mail it was given the meeting ID. This problem.
Yeah, I'm sorry. So these are the pre-text tasks. Okay, now as I told you, we will see one example with SimCLR because this is the fundamental self-supervised learning framework. So this is like you can see the structure of SimCLR self-supervised learning framework. Sim stands for simple, C stands for contrastive, and LR stands for learning. So this is a simple contrastive learning. And here you can see that, okay, the input image X, it is fed to this self-supervised learning architecture to produce the two projections Z and ZS. So here you can see that these are the two different views. The views are generated using any pretext task. They may be rotated images, they may be colorized images, or like you can apply any pretext task and two views of this images are generated, input image. Then they are compared with this original image and this augmented image, they are compared, and embedded model is used here. I'm going to discuss this with one real example. So I'm not spending much time here. And here you can see that two projected images are generated, and then they are like contrastive loss is used by this SimCLR framework. And here they are using MLP. This is multi-perceptron model. So this is used here. This can be used for different tasks in computer vision. It can be used for segmentation. It can be used for object detection. It can be used for classification. So based on your objective, here you have to use this model. That what is the objective? Adversarial learning, like here you can see that I forgot to mention that point here. I'll show you. Like here you can see that we also have models which use this adversarial learning. So they are different. Yeah, so they fall in this category, which they use generative and discriminator models. So all this here you can see that most of this frameworks, they are used for computer vision applications. These are used for NLP. So they have different applications, and some of them are based on generator and discriminator also. Okay, so before we see example with SimCLR, let's recall the puzzle which we used to play when we were kids. Like you are given, this is a matching problem. You are given one image and you have to match that it matches with which of this image is on the right side. So being a kid, what we do, we check that whether it looks similar to this, it looks similar to this, this or this. And accordingly, then we check that, okay, one by one, we check with all the images, and then you can see that, okay, here is the matching. Okay, so we solve this puzzle like that. So this is contrastive learning, which gives whether two images are same or they are different. Okay, so when we want to solve any problem using like any computer vision problem using this self-supervised learning, this is how we can formulate the problem. The first step is we need examples of similar and dissimilar images. So like positive and negative images in case of automated disease diagnosis, we need positive and negative images. So we need similar and dissimilar images. That is the first step. The next step is, after that, if we use supervised approach, it works like this, right? Okay, now here you can see, but how can we automatically generate pairs? Labels. So there we need, like, if it is supervised, it's okay. If it is label data, then it will give output like this, that these are similar and these are not similar. But if it is not supervised learning, then is there any way to generate the labels and to know which are the similar and which are not similar? So the way is we can use supervised learning here. So the next step is ability to know what an image represents. So that is visual representation needs to be learned, and it needs to be learned thoroughly. It needs to be learned in deep. Okay, so visual representation, at the end, you get the features in this vector. So visual representation needs to be learned. So here, like, we can use self-supervised learning model here, which will output features. The third point is ability to quantify if two images are similar or not. You were asking this, right? You were asking this. So this is the third point. It has ability to quantify if two images are similar or not. So at the end, we check whether they are similar or not. So these are the three main steps when we apply self-supervised learning. Okay. So let's see now with this example, like earlier, I showed you the framework, basic framework of SimCLR. So here you can see that you can use any data augmentation task. It may be rotation, colorization, any two. SimCLR allows any two augmentation tasks because two images are generated here. This XI and XJ. So any two augmentation operations can be used in SimCLR from that basket of operations. So this X is original image and both are augmented. Both are augmented, applying different operation. One may be rotation and second may be colorization. So two augmented images are generated. Here, like your backbone model is used. In original SimCLR, they have used ResNet 50 here. Then next, it generates the representation. And then here, as per your application, you have to use that whether multi-perceptron or some other model based on your objective, that whether you want to, whether you are carrying out this for segmentation, classification or what. Okay, so then finally, these two are generated, projections are generated, Zi and Zz, and it checks the similarity, like how similar they are. And accordingly, next iteration, it has to, like, they are using contrastive loss function, but that's what I told you, that different self-supervised learning methods, they differ from each other with respect to either loss function or backbone model or application. So different frameworks, they are using different loss functions. I'll also demonstrate the results of our work where we have used a different loss function. So even in SimCLR, you can try with different loss function for your application, whether it is producing good results or not. So it also depends on your application domain. Okay, so according to those 3 steps, now let's apply these 3 steps to real problem. So suppose this is a raw corpus of images. And this is the first step, which has further sub-steps, you can see. Self-supervised formulation. The first is data augmentation, as we have seen. Remember these steps. Yeah, these are the steps. Data augmentation, right? Then we are using the backbone model. Feature vectors are generated, and finally, so we'll go step by step. This is raw corpus of images. And the first is data augmentation task. So generate batches of size n from the raw images. And here in this example, we have taken batch size 2, okay, for comparison, for simplicity. But in original paper, they have taken this batch size. That also I have mentioned. But for demonstration purpose, here batch size is kept 2. So that understanding would be easy, okay. So here you can see that this is whole training corpus, which is divided into batch size 2, whole corpus. Okay, then the next step is apply a random transformation function T that takes an image and applies a combination of any two. As I told you, in SimCLR, we are using 2 augmentation operations, but they are using 2 augmentation operations from this set of operations, either crop, flip, color jitter, or grayscale. So any 2 of them can be used. And then this is like data augmentation, original images. When you apply any data augmentation operation, original image is converted into transformed image. So you will have this transformed image. Okay, so here you can see that, like, these are 4 operations which you can apply. So I have shown that what happened in that. See this. So 4 operations are there. We have to use any 2 of them, but just for like to show you that what happens when we apply these 4 operations. Okay. And this is cropped. Okay, then next, for each image in this batch, a random transformation function is applied to get a pair of 2 images. And thus, for a batch size of 2, we get 2 cross n. In our corpus, how many images are there? In our corpus, how many images are there? 4, right? Yeah, but 4 images are there, we have considered. So oh, sorry. Yeah, so because there are 4 images and the batch size is 2, 2 cross 2 is equal to 4 total images, because we are dividing those images into batch size 2. Okay, so 4 are divided into 2 batches. Okay, now this is the preparing similar images in a batch. So batch size 2, random augmentation, you can apply any from that set. And here you are getting pair 1, pair 2 and augmented images like this. Okay. Then the next is base encoder. As I told you, in original SimCLR, they have used ResNet 50, but you can change backbone model as per your requirement application. So each augmented image in a pair is passed through an encoder to get image representation. So these augmented images are passed to this ResNet or some other backbone model, maybe pre-trained CNN or like maybe any other pre-trained CNN like GoogleNet, ImageNet, or it may be custom CNN, your own CNN. Okay, so you have to pass this augmented images to that backbone model, so that backbone model will learn from those representations and the learned features will be given as an output in this vector. Yeah. So encoder, like you can use any pre-trained model, and this projections like this are given. These are the features learned from those images. Okay, so this is the original SimCLR where ResNet 50 is used, and this is the size of that feature vector. It is 2048, right? Okay, now the third step is projection head. The representations HI and HJ. HI and HJ are feature vectors. HI and HJ are feature vectors. So this representations HI and HJ of the two augmented images are then passed through a series of non-linear, dense, ReLU and dense layers to apply non-linear transformation and project it into a representation Zi and Zz. So our final output would be, at the end of one iteration, the final output would be Zi and Zz. This is denoted by this in the main paper, and it is called projection head. So at the end of this, you are getting the projection head Zi and Zz. Okay. Now here you can see that the next step is tune the model. One iteration is over. Okay, so you have to tune model, like you have to make the necessary changes in next iteration. So each augmented image in the batch, like we are getting this embedded vector Z for it, and we will now, what we will do, we will find the similarity. So how can we find the similarity? Here we have used the cosine similarity, because they have used cosine similarity in the paper. Okay, so similarity between two augmented versions of the image, it is calculated using cosine similarity, and for two augmented images Xi and Xj, the cosine similarity is calculated on its projected representation Zi and Zz. So here you can see that similarity of Xi, Xj, and this is cosine similarity of Zi, Zz. So like that's why I told you that to understand self-supervised learning, you should have fundamental knowledge of loss functions and neural network and deep learning models, etc. Okay, but later you can explore. Okay, so this way you will get output that pairwise cosine similarity for entire corpus. Okay, so here you can see that if they are like this are more, they are matching, this are matching. This is like slightly matched with this because they are ket. Okay, but here you can see that this is not matched with this. So at the end you will get the similarity between these images. Okay, then calculation of loss. So SimCLR uses contrastive loss. So here it is like first the augmented pairs in the batch are taken one by one, pairs, because they are augmented pairs. So here and next apply the softmax function to get the probability of these two images being similar, whether they are similar or different. So probability is calculated after that. So here you can see that this is take each pair, right, augmented images in batch. This is the first step and this is the second step that softmax is used for classification, that whether those images are similar or they are dissimilar. And if they are similar, like when you calculate the probability, of course, if they are similar, you will get high probability for that. And if they are dissimilar, you will get low probability. So this is how then the loss is calculated for a pair by taking the negative of log of the above. This is like known to everyone. This loss function, those who are working in this field, this is cross entropy loss function. So this is known to everyone. This formulation is the noise contrastive estimation loss. But instead of this, you can also try with other loss functions. Okay. So this is for second pair and so on. So finally, after you calculate loss for each pair, finally, we compute the loss over all the pairs in the batch, which is of size 2, and we take the average. So that gives the overall loss. So first you have to calculate loss for each pair and finally take its average. So this is for different pairs. You can see that pair 1, pair 2. Here we have only 2 pairs because we have only 4 images in corpus and batch size is 2. So we have only 2. But if it is a corpus is large, then several pairs would be there. And it depends on batch size also. Yes. We have two encoders, it is same. 2 backbone models, but they are same. They are not different. If it is resonate, then for both the pairs, the resonate will be used. No, we can do that, but here it is not like that. It is for demonstration purpose only. It is one backbone model only. So you have to go pair by pair. Like if there are 10 pairs, then we don't have 10 encoders. Correct. No, they are not different encoders. Like it is one only. For demonstration purpose, I have shown that this way, like it is doing, but it is done in sequence only. Okay, and if downstream tasks are there, then finally, like fine tuning and multiple iterations would be there. So this is the overall self-supervised learning framework. Yes. Yeah, that is the purpose, right? Yeah, it's trying to do that only, but at the end, depending on the model, it will generate that which are the similar, which is the group of similar images and which is the group of dissimilar images. No, we are calculating. No? We are calculating dissimilarity. We are using cosine similarity. So from that, it will come to know which are the similar and which are not similar. That's why we are using cosine similarity. We are taking, we are taking negative samples. We are taking negative samples. To avoid accuracy paradox, training must be provided with positive as well as negative samples. Otherwise, it would be a biased output. So we need both type of samples when we want unbiased results, outcomes. Right? Okay. Now that was one architecture. I'm not going to discuss this, but as I told you that how they differ from each other. Now here you can see that only difference is here, that this is called momentum contrastive learning. This is MOCO version 1 is also available. MOCO version 1, I have not included architecture, sorry. MOCO version 1, MOCO 2, they came after SimCLR. So these are the basic self-supervised learning frameworks, and then so many were proposed. Okay, so this we have implemented for our own research, and you can see the results. I'll show you. As I told you, we want to label this data. This is labeled data set, but it is labeled for actions, and we want to label it for tool also, because which is, as I told you, for same tool, 2 different actions are there, and sometimes misclassification happens. So we want to tool, because if tool action mapping is there, then it will give us accurate output that what action should be performed. Based on tool, it will tell us that which action should be performed next. So we want to identify tool also, but we don't have labels for tool. So we want to assign labels for tools. So we use self-supervised learning framework for this. And we use SimCLR. And you can see these are the results with SimCLR. We got 88.41 accuracy and 98.57 for Cypher 10. This is our data set, surgical accents 160, and this is Cypher 10. So when we applied SimCLR using this two augmented tasks, I told you that you have to choose any two augmented operations. So we chose this normalization and resize, and we got this accuracy and loss. And this is the collapse level. But when we use, okay, and after that, we thought like, can we try with more augmented tasks? So we proposed our own self-supervised learning framework, and we call it multi-contrastive learning method, where we are applying more augmented operations. So here you can see the operations which we are applying: normalization, resize, rotation, random crop, and colorization. And when we tested this data sets with our own self-supervised learning framework, we got good results comparatively. Here we are getting, you can see that 99% for our surgical actions 160, while with SimCLR we were getting 88.41. And with for this Cypher 10, we were getting 98, and here also we are getting like 98 points, almost same. But for our surgical actions 160 data set with more number of augmented operations, we are getting very good results. We also checked results with different loss functions. As I told you that all self-supervised learning frameworks, they differ with respect to major 4 things. And so we applied multiple augmented tasks. Yeah. Collapse is like model becomes stagnant. It stops learning. So it is related to overfitting. Yeah. So it should be like, here you can see that this is, it should be less. So with our proposed self-supervised learning framework, it is 0.01. It is more than it's not good. It is always between 0 and 1. It is always between 0 and 1. And for our proposed framework, it is 0.01. So it's giving very good result. If it is less, you will get good accuracy. Okay, so this is our multi-CLR framework, like how it works. You can see that this is the input image, and these are the augmented images for this input image. Different augmentation operations, which I mentioned on previous slide, right? They are applied. And then this is the backbone model. Here we have used, like we are still working on it, and we have not used any pre-trained model. I would like to tell you why we have not used pre-trained model, because all pre-trained models, they are CNN models. They have been trained with natural images, and those images are labeled, like it's easy to label natural images because they need only human knowledge. We can label those images. But medical images, they need expertise. Medical experts can label those images, and we don't have labeled medical images. So when we apply those pre-trained networks to our medical image domain, they don't produce good results because they are not trained with those images. So better we apply self-supervised learning. It will learn on its own, and it will comparatively produce good results. So here we have used, like backbone model, we have used our own custom CNN. So we have designed CNN, our own architecture, CNN architecture. We are not using any pre-trained CNN. So that is used, and here you can see that at the end, it will generate like this. It will discriminate that which are the similar and which are the dissimilar images. So at the end, we are getting this output. Here you can see that this is for our proposed model, and this is for SimCLR with the same data set, surgical axon 160. If we apply once SimCLR to surgical axon 160, we are getting this output. So it's not discriminating between the images, similar and dissimilar images. While our proposed multi-CLR, it is discriminating between these two groups. And this is just to see like histogram, you know, what's the purpose of histogram? We can skip this. Yeah, so that's all from my side about the self-supervised learning. Just for your information, I work in this domain, and these are the books. This is also published, Explainable AI Foundation Methodologies and Applications. So if you are interested in this domain, Explainable Artificial Intelligence, you can refer to those books. And this is Tracking and Preventing Diseases with Artificial Intelligence. This is with CRC Press, Knowledge Modeling and Big Data Analytics in Healthcare. So that's all from my side. Thank you so much for patiently hearing.
Just one.
Ma'am, you mentioned it in one of your slide that we can fuse different image modalities.
We can
Fuse image
yeah,
modalities.
different image modalities.
So you were talking about fusing like say ultrasound and MRI are
Yeah.
same kinds of ultrasound.
No, both way it is possible. I'll tell you, different image modalities, they reveal different kind of information. Like some image modalities, they are used to assess only anatomy of parts of our body, and some image modalities are used to assess the functioning of the internal parts of the body. So we have different types of, that's why we have like different types of image modalities, because their purpose is different. They reveal different kind of information. So you can also fuse two different modalities. For example, we too know that when we go for diagnosis of any bone related disease, if it cannot be diagnosed from X-ray, then doctor prescribed us to go for MRI because it gives detailed information. So you can also fuse like CT and MRI for brain related like disease diagnosis. You can also combine X-ray and CT. You can also combine like pre-operative CT and pre-operative and intraoperative CT. For example, suppose it is a problem of brain tumor navigation, and suppose you are using MRI images. So you can use pre-operative MRI image, and sometimes with pre-operative MRI images, it becomes difficult to localize that brain tumor because like things are not clear. So at that time, during operation also, the medical image can be taken, and it is called intraoperative medical image. So that pre-operative and intraoperative can also be combined, and the modality may be of the same time. It may also be of the different type. Intraoperative may be of CT and that may be of MRI. So all these combinations are possible.
Reliable these annotating tools for making annotation.
Sorry?
You were telling about these annotating tools that are used.
Yeah, annotation tools. Yeah.
So how reliable are these? Because like medical images are very difficult to
yeah, absolutely right. Like for that also, but only thing is it takes less time. Once you annotate data with those tools, you need to get them verified with experts of that domain. But labeling takes more time compared to verification. So instead of asking them to label that huge amount of data, you can label those data with annotation tools. You can get them verified. And if you feel, okay, this huge amount of data which is labeled with this tool, it is correct, they have verified, then for rest, like you can believe that it is giving correct labels.
Verification is needed.
Verification is needed. We got those images verified from surgeon. Yeah. Collapse level, if you neural network, if you have studied, you must be knowing overfitting and underfitting problems. So this is the term related to ANN, and you need to like learn all the hyperparameters related to that how it is calculated.
What is the formula for calculating?
What is?
The formula.
That's what I'm saying, that formula I have not included here, but there are different ways to overcome overfitting. So different methods are there, and it depends on the method, that which method you are applying to overcome the overfitting problem. So accordingly, like you can choose the formula, that which method you are following. Yeah. How are the negative samples here? We are not generating when we have that unlabeled data set. I told you that self-supervised learning is used when you want to learn from unlabeled data. So that unlabeled data, that corpus has positive and negative samples both. Like we don't need to generate. It will generate based on the data you are providing to that self-supervised framework. So that corpus should have, like here we have seen in the example that we have cat also, we have elephant also, we have other two images also. Right now, when I feed cat, it knows, right? The cat, it has learned about the cat. So that sample was there. So whatever you have available in your corpus, it will learn from that. Like it automatically won't generate negative samples if you don't have negative samples in your corpus. It should be there in your corpus. Like for example, we worked on one problem, hypothyroidism detection in infants during early stage. So we collected, like it was very difficult for us to collect data for this research because no data set is publicly available. And we consulted several pediatric endocrinologists to collect this data. And there are like, only in cities you will find pediatric endocrinologists. And there was no reason for them to take picture of the patients when they were consulting them. So they did not have any images of of infants suffering from hypothyroidism. But then we requested them that you collect over the period of, because it was dissertation work, it was 1 year work. Then we requested them that please collect this kind of images for us over the period of 6 months so that we can use. And we could like there are privacy issues also, ethical issues also. So among several pediatric endocrinologists, only a few, 2 to 3, they agreed that, okay, they will like, I gave them consent in writing that we will use this for research purpose only. And then they provided us images, and around 143 images we could collect of infants suffering from hypothyroidism. But at the same time, we also collected images of healthy infants. Because to avoid accuracy paradox, I need to fit both to my model, that these are positive samples and these are negative. It was easy for us to collect the images of infants having no hypothyroidism, healthy infants. But it was difficult to collect images of infants suffering from hypothyroidism. So you need to feed. (143) positive samples, and you roughly, like ideally you need equal number of negative samples, but roughly they should be equal. If not, like if classes are unbalanced, then you have to apply like that to avoid that underfitting and overfitting problem. You have to apply the methods, right? Similarly, when negative data, augmentation, and then it will learn. No, it won't help. Here, the purpose of self-supervised learning is only to make that model learn on its own to generate labels for that unlabeled data. So, like it won't do that. What you are saying that positive and negative samples, it will learn. So this is like a base model, SimCLR. You can first try with it. You can apply different loss functions. You can apply different backbone model. You can test it with a small set of images, and then like several questions will be generated once you experiment it. That what if this, right?
Hello, ma'am.
Yeah. Hello.
This side.
Okay.
Hello. It was really informative. I want to ask, like I'm training a model, a CNN model on the base of image data set. So which basically it's a classification based model. So which classifier should be used?
Which classifier? Like again, generally what we do that we apply different classifiers, Naive bias, SVM, decision tree, and then we, based on the accuracy, you generate the confusion matrix, and based on the output only you have to select.
The very same work you can do in scikit-learn also. If you use scikit-learn instead of doing CNN, you can do machine learning also. But that is a little bit time taking.
So scikit-learn, it won't take time. The models are available, they are readily available. Just you have to divide your data in 2030 or 2575, and then you will feed it. This is the simplest way to implement machine learning models, scikit-learn. Otherwise, if you use TensorFlow and Keras, you have to like TensorFlow allows you to build your model from scratch. You can customize your model, and Keras is also considered good. So most of the existing applications of Google, machine learning based applications of Google and other Facebook and all, they are using TensorFlow and Keras. But scikit-learn is only for students. Like if you don't know how to build model from scratch, you can use ready-madely available models in scikit-learn and you can check. But if you want to try with different hyperparameters of that model, then you have to go with that TensorFlow and Keras only.
So with TensorFlow, we can increase the accuracy and specificity.
It's not like you can increase, you need to test it. Like you can customize your model, you can hypertune your parameters. So that way, like you can tune your hyperparameters and you can check.
In scikit-learn, the main part is the feature selection that we have to do. That
But
takes most of
everything is
time.
available, like functions are available for everything. You are not doing anything. So for example, for decision tree, I think the size of the tree is decision tree. They have used, no, sorry, for random forest. They are using for each group, they are using 5 trees or 10 trees. So it is fixed. But if you want to check what if you take 10 number of trees or 8 number of trees in that random forest, then you have to use, like you have to implement that model from scratch. Then you do not use, like I do not recommend for this kind of experimentation that scikit-learn.
Okay.
For nearest neighbor algorithm, like K nearest neighbor. So KNN also, K is defined there. So if you want to check for different K value, yes. Yes, sir. Yes, sir. Hi. Okay.
This is a problem we faced a couple of years back. We wrote a proposal with a startup analyzing it, but then we couldn't find people to annotate the images. Basically, they were MRI, this one. So can we still use your technique to analyze data and come up with something?
The entire session was on that part.
So sorry, I missed that part.
Yeah.
So maybe I'll connect with you later.
Annotation tools are there, sir. And using those annotation tools, we can label data. And that is one way that using annotation tools, we can like label data and we can get that data verified from experts.
Right.
That is one way. Second way is self-supervised learning, which we can use.
Okay, sure. Thank you.
So my purpose, like the objective of this tutorial was to introduce a new flavor of learning, self-supervised learning, which was introduced in 2020. Because otherwise everyone knows supervised, unsupervised, supervised, unsupervised, and they don't think beyond this. Less people know what is semi-supervised, right? Most of you know that what is supervised and unsupervised. So now you have learned that what is self-supervised, how it works, like major steps, and some frameworks are available. And you can explore, you can experiment, and you can check that for your application, for your set of images, which model or which learning techniques gives best results.
Ma'am,
Yeah.
I have a doubt. Like while we work on GAN architectures, it work on like benchmark data set like MNIST, fashion MNIST data set and all. But while we change that to our own custom data set, it is not having that much performance on that. So what all reasons were
Why
there?
we change
The data set? Like if we use our own data set, it is not showing that much results while we are using DC GAN or cycle GAN in our own custom data set. So what are the reasons?
No, like for custom data set also, like for our data set also, it gives like you also have to here try with different GANs. And here also you need to change the parameters. Like in GAN also, you can change the values of all the parameters included in the architecture. And you can check, like we have used for ultrasound images. My one paper is also there on that. It's giving good performance for ultrasound images, which we have collected from radiology center. And we applied DC GAN and some other GAN, and we also modified its structure and we applied it, and it's giving good result. So it also depends on the type of data you are feeding to that GAN. If you have a good
with the MNIST fashion data set, we are getting the same accuracy or same images.
You have tested with all like available
yeah.
GANs or only DC GAN and that
DC GAN we are trying.
C GAN, DC GAN, and so many different types of GANs are there. So if like possible, I'll show you after this session that these are the types of GANs available, which you can apply to medical image modalities. So you can try with all those GANs.
Thank you.
Diffusion model, yes. Correct. Yes. Yes. accuracy of all these models, it doesn't depend on any one parameter. It depends on so many parameters: amount of data, quality of data, setting of parameters, loss function, number of iterations, so many parameters. So like you need to test with different combinations of all these things, and then you can conclude that with which model you are getting good results.
Yeah, are there any questions? Last ones? No? So then I would like to thank, because there are enough questions already. Thank the speaker.
Thank you so much.
And there's a token of gratitude from Triple IT. So I would like to hand it over to
Thank
you.
you. Thank you.
Thanks for the talk. And then we'll move to the next session, the plan. Is there any tea break or something now? Okay. So you can have a tea now, and thanks for staying in an interesting session. I could see faces, they were all really brighten up. So it means our food is good. It's not very heavy to make you sleep. Okay.
Yeah. Hello, Philip. Are you there? Philip.
Yes, yes.
You are there. Okay. You have Longbing and Yungsing and hello, Longbing, are you there? Yeah.
Yeah, hi.
Hi, hello. Yeah.
Hi, Krishna. How are you? And hi, Phil.
Fine,
How are you?
fine. Everything is fine. We
Good.
got some participants. Let us wait for a few more minutes and we'll start.
So, yeah, Rinxin, how are you?
Madam. Yeah, hello. Hi.
Thank you.
Yeah. So just 2-3 more minutes, we'll start. Okay. Yeah. We are waiting for Jaideep and Masaru. You can project them and show that the participants to them. Return camera. Yeah, this is our hall. Yeah. No, you just round it. Just we had a tea break now. People started coming. So then we'll have. We got about 100 to 120 participants normally. At this time, we got more than 70 participants, 70 now. And this is the started coming. So, Philip, let us start then 3:30.
Okay.
Okay, so Professor Philip, now we can start. I think Jaideep and Masaru may join due course. You can start introducing the panelists and you can just explain, make a presentation. Thank you.
Okay, thank you.
And we are going to a panel session. So I request Professor Philip from Shenzhen University to just chair this session. Thank you. If you have any doubts, I will communicate. Thank you. Yeah.
Okay, welcome to the panel about
the... Yeah, thank you, sir. It's very cold, it appears. You are muted.
Let's see, can you hear me?
Yeah, we can hear you.
Great. All right.
We got about 70 to 80 participants now. You can show this camera again. Yeah, so.
How's going, Jaideep?
Like that.
Well, actually, I'm in Delhi right now, but it's so cold and foggy.
Okay.
Oh, yeah,
That's why I'm wearing my Minnesota hat.
Sorry, you're the United States.
No.
Yeah. Okay, come on. Okay. So now actually we are going to wait for Master Kisturigawa whenever he joins. So I request Professor Philip to chair the session. You start introducing the speakers, then ask them to present starting from Longbing. Okay? Thank you.
Okay. So welcome to this panel. This panel is about the data science for the sustainable goals. The goals is about sustainability, eliminate the hunger, the poverty, provide the clean water, the good health, education, reduce inequalities, have the responsible consumption, protect the life, and fight the climate change, among other things. So in this panel, our topic is about how data science can contribute to reaching this goal, which are set for 2030. So let me introduce the expert. We have 5 international experts. We are very happy to have today Professor Longbing Cao from the University of Technology in Sydney, editor-in-chief of the Journal of Data Science and Analytics and founder of the Data Science Institute also. We have Professor Santanu Choudhury from IIT, who might join later. We have Professor Yin Ko from University of Auckland in New Zealand. We have Professor Jaideep Srivastava from the University of Minnesota and Professor Masaru Kitsuru Gawa from the University of Tokyo. I think you can see the biography on the website. All of them have the amazing achievement. They have received many awards and so on. To go a little bit faster, I will not introduce all the achievements of our experts. So I would like first to the format for the panel. Each expert will talk for about 10-15 minutes, more or less, to introduce his perspective, and then we'll have some questions from the audience. Okay. So I would like to invite first Professor Longbing Cao to start.
Thank you very much, and I really appreciate it. So share, I just prepare a few slides here. I particularly focus on one topic here, actually, because data science, obviously, the courage and spread, just so big. So I mainly focus on the beyond IID thinking. The first I refer to independence, and the second ID refer to identity failure. So if you are familiar with statistics, so this, is a very basic, assumption of what applied in information theory and in machine learning, and also deep learning as well, largely. And in this particular setting, SDG, problem, behavior, and data. So let me give you a few, perspectives and about this concept, what I call a non-ideas. So in the 17 SDGs, as what Philip just mentioned, I think more or less in general, we can extract 2 major data challenge or behavior challenge or problem challenge related to complex coupling relation direction. So that's one part. Another part is related to complex heterogeneity. So I will explain them. I'll give you a couple of examples related to SDG. The first one is smart disaster resilience. So that could be related to crisis and emergency, natural like climate, weather, et cetera, as well as technology, emergency, crisis, and disaster as well as intangible ECD as well. And the issues related to the non-IDs, the complex interaction and heterogeneity, could be related to the whole process from early warning to optimization to prevention, as well as the data complexity and the data characteristics, as well as from resilience or management perspective, so many aspects actually could involve the 2 key aspects I just mentioned. So another major issue related to SDG, of course, is infectious disease like COVID-19 pandemic, and that could be related to the virus itself, the disease, and also other social, economic, and et cetera aspects. in inner aspects of these three major categories, there are, complex relationship and also, heterogeneity related there. And of course, in the natural and artificial system like psycho-physical social system, this complex relation heterogeneity stay there as well. This one more related to health and a little bit more specific, for example, for diabetes. So there are different signs there. The 4 signs related to frequent urination, weight loss, lack of energy, excessive thirst. If this is 4 signs happen together on one person, unlikely, this person may suffer from diabetes. So it means, the features correlated and, interactive. And also we understand these 3 or 4 signs, they may follow different distribution and their structure, their format or semantic, and may be different as well. So this is related to something what called heterogeneity. So it goes beyond the distribution, it also refers to many other things. Now, of course, the interaction coupling, what I mean here, it goes beyond the normal perspective like correlation, association, dependence, and causality, what we usually talk about. And that actually comes to something I call a non-idealness. So it goes beyond the statistical ID. It's basically, not independent, not identically distributed. So if you put the opposite, it's basically ID, and then in the statistical sense, it's called a non-ID. But my definition here goes beyond this statistical, framework and to many other things, as I highlighted in this paper, beyond IDs. This non-ID thinking, very general from many perspectives related to very, fundamental things related to computational unit as well as to quantification process evaluation and for the 2 major aspects like heterogeneity and interaction, each of them we can further decompose them into different, aspects and properties, and then there are some many aspects has been addressed very well in the current theory, but there are also many other issues which have not been addressed. So in the current machine learning and statistical, typically like a complex learning problem in SDG, what we do is that we assume there's the ID assumption, and then the objects they are independent, they follow the same distribution, then we can build an objective function and to learn it. But in reality, of course, we understand it's complex problem. We have to actually respect, try to learn the complex interactions and heterogeneity there. That's called a non-ideal learning. And that's also why sometimes we see, these kind of things related to, the bias and variance. It's called, either underfitting or overfitting to get a perfect fitting, and often not so easy, right? Not so for complex data, complex behavior, not so overall. And this problem actually also applies to deep learning. So in deep learning, we have issues like network vulnerability, distribution vulnerability, domain vulnerability, et cetera, So why the problem, appears here, with a deep model so advanced, but still there are some issues there. Also, some of the key issues related to the non-ID is actually here, related to sampling, related to, the training and testing that's called, out of distribution in particular, and also, related to the architecture design, et cetera. And this diagram actually shows, 2 dimensions. So one is that in the statistical form, statistical ID and non-ID. So it's basically got the data that for the either independent identity distributed, that's called ID. Otherwise, you have, non-independence or non-identity distributed. So you've got basically, 4 spaces. But I further extend this ID view to more broader interaction and heterogeneity, and then you got a homogeneity and heterogeneity, and that go beyond the the dependence theory, and also go beyond the distribution itself. So it's, as I mentioned earlier, and this perspective actually goes to almost everywhere, every aspect of learning or data pre-processing, from the feature engineering to statistical learning, to deep learning, to reinforcement learning, to outlier detection, to recommender system like applications like even federated or transport learning, et cetera, et cetera. So I just show here this diagram, probably a little bit too small, but just to give you a perspective that most of the current analytical and learning theory in whatever AI data science could be really rethink and revisited and so that we can get it really some new perspective, understand or to make the current theory and the tools more powerful. For example, so this is a paper I wrote to review the 70 years of AI and the 6 perspective. The major AI aims and goals, or the different objects to be focused, or the major intelligent paradigm. So many of them we can actually further think about their complexities or their capacity or capability from the the broader reaching ID perspective. So that's basically I want to summarize. So probably require a little bit more transformative and transdisciplinary translational thinking beyond the ID, beyond fitting, beyond the data-driven, beyond the hypothesis and model-driven. Probably like SGD. So whether we can really think about some intrinsic or intricate nature essence behind the data, behind the problem, behind the behavior, and even behind the outcome, and so that we can do something further to to understand the underlying problem better. So that's my very brief perspective. Hopefully I haven't used too much of a time here. Finished. Thank you. Can I hear you? Yeah, Filippo, you mute yourself. Still cannot hear you, right?
Philip, we cannot hear actually. No, we cannot hear. Anyway, so actually we cannot hear Philip. So I now, can you, so Longming, you want to have some questions now or you want to take at the end?
Up to you. Yeah, I probably have to leave a little bit all friends and yeah. Sorry for that. Yeah,
We'll
but
take after just after finishing everything, stay for some more time. So
okay, I'll try. Yeah, okay. Yeah.
Now I request Professor Jaydeep Srivastava to just make his presentation. Thank you.
Okay, let's see. Can everyone hear me? Okay. Yeah, please apologize. I apologize. Please bear with me because there's a little bit of maybe some ambient noise. I'll try to reduce that. Okay. So, and also I will try to keep it brief so that we have more time for questions. This is such a broad topic that I even felt that having a presentation may not even be worthwhile. Okay, so first of all, if you look at the various sustainable goals, I mean, Longming had a slide which talked about the 17 sustainable goals. Clearly, it's a very, very broad spectrum. And some of them, so I'll try to make sort of 2 or 3 big points to begin with. So let's take some of them. So first of all, there are some of them which concern some parts of the world and do not concern other parts of the world. So that's sort of one dimension, or they concern or they affect different parts of the world to different degrees. Let's say whether it is poverty or food security, water security, sanitation, and so on. So there's a whole spectrum. So that's one dimension I would say. A second dimension is that there are some factors that affect everyone, regardless of the economic situation or maybe even very often geography and so on. That is factors like climate. Climate affects everyone. So so there are some, and then there are some problems that affect only some parts or don't affect other parts and so on. So what this does, so the thing is that across all of these different kinds of sustainable goals, different societies in the world, different countries are at different points along these, the spectrum. If you think about this as a 17-dimensional problem, really. So what does that heterogeneity mean? What it means is, let me add one other factor, which is that different societies have different amount of resources to address them. So what does all this heterogeneity lead to? And to some degree, a lot of interwoven commonality. And what that does is that it creates different kinds of concerns for different societies and different people. Okay, so for example, when someone talks about food, agriculture, someone is talking about agriculture and maybe providing calories to people at a level so that they don't starve. In other parts of the world, people are talking about calories at a very high level. So, and the kinds of environments, the kind of foods and so on that people are concerned are very different. So even the problems that people are solving under each of these umbrellas, each of these 17 different umbrellas or buckets, if you will, happen to be very, very different. So, and of course, most of the money in any society that is spent in problem solving is spent on internal problems, on internal efforts and so on. And then of course, organizations like UN come together and say, well, we have all decided to solve some global level problems. Okay, so where am I going with all of this? So first of all, I wanted to bring to light the fact that this, obviously, given the scope of the problem, these are complex problems with many different dimensions, varying amount of, different sort of, even along these different dimensions, the nature of the problems are different level of resources available, and different thinkings. So this is what makes it even more challenging to and I work a lot with some of the government efforts in India as well. And what have I noticed? I've noticed is that the problems that the National Science Foundation in the US will fund are problems that are mostly over there. Okay, some of them might be of use to other parts of the world, some of them may not be. And similarly, every country that is doing, and I'm using the word country because those are the organization units of the world, because they're the ones that collect the taxes and decide the policies, that the set of priorities that are set are quite different. So that is an important consideration to take in mind. So one of the important things to also remember from that, as a fallout of that, is that apart from, when we look at these problems, we have to see that if a particular, so let us say in a particular society, in a particular country, in a particular environment, which of these problems are the most relevant, and what is the nature of those problems in that particular environment, and then see where the different solutions, if others have already addressed them, either right now or sometime in the past, then maybe just sort of see what has worked, what has not worked. So the point is that in many different, there are lots and lots of efforts going on in every single one of these areas. For instance, there's a lot of efforts. Clearly, at one end, there's a lot more. If you look at things like climate, right, water, these are areas in which there are international level efforts. But of course, as we also know, there's sort of challenges of sort of politically people not coming to an agreement very often. Okay, then there are efforts like, for instance, let's take food. Okay, food and food security. Food security problems that are being addressed, let us say in the US, for example. So I happen to live in the central northern part of the US, which is extremely cold. The agricultural efforts over there are how to grow corn and soybeans in a very short time frame, which is a time frame of about 4 months, because that is the total growing cycle in the whole year. Okay, so people are studying, how to have a faster growing corn, which can go from seed to harvest within about 120 days, right? Which is not the concern in India, for example. In fact, our colleague Dr. Krishna Reddy has worked a lot. He works a lot with agriculture, and he is not concerned, or at least the farmers he works with are not interested in growing corn within 120 days, right? Because that's not the concern. So there are different problems being addressed which are respective to the different environments. And in all of these different areas, some overall efforts are going on, some different kinds of efforts are going on, and so on. Okay. Now, having said that, let me give a very brief example of like a specific kind of area related to this I work on. One of the areas these days that I'm very interested in working on is, and I'm working on actively, is on health and wellness. Okay. And it is, well, these are things that have been known for a long time in many different societies, that health and wellness are highly correlated, in the sense that you will have good health, and the sort of the separation between these two terms means that health, something becomes a health issue when you have to talk to the medical community about it, whether you go to a pharmacy, whether you go to a doctor, or whatever else, right? While everything else that you do without touching the medical system is wellness. So if you go for an exercise, if you have a proper diet, if you have a proper sleep, you're taking care of yourself, and that all comes into wellness. Now, we all know, everyone has known since time immemorial that wellness and health is very integrated with each other, and how you lead your life is extremely important towards your health. And of course, how your health impacts the way you lead your life. So there's a constant feedback loop between the two. Classically, though, a lot, especially in the Western world, a lot of attention in terms of money, resources, research, and so on has been given on healthcare. That means when you fall sick. Yes, there are things like wellness checks and so on, but classically people have not taken it that seriously. But now the realization is coming a lot, and driven even from economic and political considerations, that overall wellness is very important. And so one of the areas in which data science is coming in a big way is the use of things like wearable devices. So healthcare model right now around the world has largely been what is known as episodic care. That means you have some kind of episode. You have high temperature, you have a fever, you have an accident, you have a chest pain, and then you go to the doctor, right? So there's some kind of a health episode that happens. And if you happen to make it to the doctor on time, then a care episode begins. And hopefully that care episode lasts a short time. You get some care guidelines, you come back, you do them, you may not do them, and then you will go to the next one. So this is called episodic care. But now what people are saying is that doctors, or the healthcare system as a whole, has a look at someone's situation only for the 0.1% of the time, or 0.5% of the time that they come in touch with the healthcare system. But what is happening in the rest of the 99.5 or 99.9% of their lives? The healthcare system has no idea. Unless, of course, you're wearing like a pacemaker, right? So then, of course, they know your heart all the time. So the question now is, what if the healthcare system could have a look, at least an abstracted look, at your life all the time? Okay, so how is that even possible? So I think of it as a three-dimensional data collection problem. So let me draw this here. Okay, so let us say Okay, my three dimensions are all the information, all the people, and all the time. So what do I mean by that? Let's say if you go to a doctor, okay, and you get yourself checked up, well, they take your blood pressure, blood sugar, all those things, and they get a fairly detailed information. Okay, that's what all the information. Okay, but how's your blood pressure doing 24/7? No one knows that. So it's a point data collection. But now supposing you wear one of these Fitbit, Apple Watch, or any of these other kind of devices. Now some level of information, your heartbeat and so on, is continuously available. So all of a sudden you've gone to all the time, okay? And the third dimension is all the people. So what is happening is that nowadays there is a lot of information that is being collected from different kinds of devices and so on, that and apps that people are using, devices that people are wearing and so on. So we are getting to closer and closer to all the information, all the time, all the people. Of course, we are not there yet, right? And it will be slow progress. And all the information dimension is not really there, because the blood pressure that can be measured in a hospital using medical instrumentation is much more higher fidelity than what something like one of these devices will give you. Okay. So we are getting a lot of, so classically, the whole episodic care has been based on deep information or high fidelity information collected periodically. And we have made a lot of progress with that. When we bring in something like genetics, then a lot of or genomics, now we know a lot about the makeup of the person, right? But what is happening now with this extra kind of information about how someone is leading their life, it is giving the potential of understanding someone's life outside of the hospital visit or the clinic visit or seeing the doctor. And the hope is that from this we can go into a way of medicine that is, I call it continuous care, but its elements are that the medical system knows, or your doctor or some nurse or whoever knows about the status of your health practically all the time. So now you can be predictive. The healthcare system can be predictive. It can be preventive. It can be giving you guidelines. For example, one of the problems with a lot of senior citizens is that beyond a certain age, their limbs become weaker. People start losing muscle. And at a certain age and beyond, if someone falls down and breaks a hip or a knee or something, then that can be quite debilitating, because they may be confined to the bed for a long time, and that has its own problems. So now there are techniques that are emerging and models that are emerging that can take care of that. Okay, they can predict from how someone is walking to whether they're going to suffer some kind of a problem. Okay, so these are so again, I started off with a very broad stroke of across the world, people are trying to solve these different problems. Clearly, most of these solutions to many of these and these problems exist in many different variations and many different ways. And there's not even a common thinking on that, but that's, as I said, because of economic, political considerations. But there are solutions that people are coming up with their own. Those solutions are all becoming increasingly data-driven. Okay, that is the order of the day. And so the question is, that on the one hand, none of these are open areas. Okay, so one has to understand, if one is intending to work in one of these, you have to look at, okay, what is your local environment? What is the specific problems you're facing? What is relevant? That is extremely important. And then look around and see what is going on in that particular area and with that particular relevance. And then I gave you a specific example of this whole movement from episodic care to continuous care, which in the Western world, for senior citizens, that actually is the way to go. But it's, as I said, it is assuming that everyone has a Fitbit or one of those kind of devices. So the US, and now just to give you the relevant part of the localized part of the whole problem, the United States, I mean, many of you might be shocked to know that at this point in time, it spends about $11,000 per person per year on healthcare. Now remember, right? If you multiply that by the population of about 340 million people, that is about 3.6 trillion. That is roughly slightly less than the GDP of India. And India is right now the 5th largest GDP in the world. So with that much amount of money being spent, what is most shocking is that the quality of health of people is not that good. So they're using an entirely different approach to trying to solve problems, which is by throwing money, reducing wastage, and so on. But those are not exactly the problem. I mean, some of them might be the same problems that everyone faces, but the solutions that are there will be different because the economics of it is different. Okay, the environment is different. So sort of, I will stop at that, and hopefully there'll be other questions that people will ask that will lead to other interesting discussions.
Okay, thank you. Thank you, Professor Jaideep, for overall very broad picture, and he gave example of healthcare as a localized problem. So we'll come back to you. Then, Philip, are you there? Can you talk?
Yes, yes.
Yeah.
Can you hear me? Yes. Okay.
Yeah.
Okay. So thank you again. The next guest to talk will be Professor Yinsenko. Please start your presentation. We'd like to hear your perspective.
Okay, I guess everybody can see my screen.
Yes.
Yes, all right, great. I think both Longbin and Jaideep had made really good points, and also adding to that a little bit. So in terms of data science for sustainable development goals, there has been lots that's been done in this particular area, whereby it's used as a blueprint to call on countries to end poverty, fight inequalities, tackle climate change, and ensuring no one's left behind, basically. And then there has been lots in terms of what's going on in the area. And on this particular screen, this is not mine. This is from the United Nations website. Is an example of work that's been carried out across the board. And if we take a look at this, there has been lots that's gone on, but I'd like to actually sort of talk a little bit about what the pandemic has shown us when we've actually gone through this. So actually with the pandemic, it showed that data science potential, AI potential for accelerating progress in the sustainable goals has accelerated this particular process immensely. Including application health, climate change, and agriculture and transport. So to do this, one of the things that came up is how do you make sure that this is inclusive, trusted, transparent as well. So one of the biggest breakthrough that we can actually sort of talk about is the role of artificial intelligence or data science in accelerating SDGs. One of the major breakthroughs that we've seen is using data science or AI to help with the vaccine productions. And one thing that can be quickly seen here is that a lot of people do believe that in the coming years, there is going to be a large advancement in how we look forward to futures when we produce medicine that is more preemptive than reactionary. One thing that's sort of highlighted through this is throughout the pandemic as well is that there is a reminder to leave no one behind. So one of the things that has happened is collecting data from vulnerable populations is pretty hard. But it is crucial to identify the challenges that they face and understand who is actually being left behind. So the innovation of technologies such as mobile phone surveys, data science, artificial intelligence technologies should be accompanied with an assessment to ensure that innovations are not inadvertently excluding or harming the most vulnerable groups. So one of the examples that has been talked about is that using digital devices such as mobile phones was the one reason that a lot of big population could not be reached during the pandemic. So this is one of the things that is highlighted with this. So access to technology is a problem. This also means that when we're collecting data, we're only accessing certain parts of the data as well. So this highlights to us that when we're building models from these particular sector or particular populations, that there is care that we have to deal with, things like algorithmic bias and transparency. So beyond that, if you think about it a little bit more, moving a little bit into the future, another particular area that I'd like to talk about is how we consume resources as the citizens of the world, and how do you manage waste and design transportation system. One of the things that is particularly interesting is how do we develop sustainable and smart transportation so that it's vital for cities and countries to reduce the impact of air pollution and improve infrastructure as well. Transportation is currently one of the largest producers of energy of CO2 emissions and is accounting for about 24%. This is based on the global transport emissions in around 2018, that's pre-pandemic. This equates to about 8 billion tons of CO2. And 74% to 75% of this is actually comes from transport of road emissions as well. So there is sort of a discussion on how do we deal with sustainable transport to actually reduce emission. There has been a lot that's gone on, and one of the things is pushing out how do we actually use micromobility as a sustainable way forward. One thing that's come across is when we talk about micromobility and also things like looking at sensors on people or humans or even on vehicles, is that we are actually collecting a lot of these data. And a lot of these data, there are some issues that we can actually raise with this, such as privacy and consent as well. So when we deal with, as data scientists, when we deal with this kind of work, there are things that we have to take care with, is whether it's compliant to how we're dealing with it and how we're actually storing and how we're, as caretakers, how we're dealing with it as well, and how we're protecting the data that's been given to us. So one of the potential things that we have to be concerned about is data sovereignty, where it is the idea of where data are subject to the laws and governance structures of the nation. For example, what are sovereignty rules about where to store the data and how to store the data and who can access the data as well. So it's kind of how do we, as caretakers of the data, how do we deal with it? The other thing that I like to actually point out, and talking a little bit about journey of what we're doing here in New Zealand, there is a big platform, and I'm going to say this is a little bit of what I'm doing as well. I am part of this particular project. So there is Tayao platform, and this is a tool that we've actually built, and this is based off how do you give back to the environment. So this particular platform is designed for allowing us to look at how we collect information, collect data, deal with data, and also produce good research in terms of data science research to solve the biggest environmental issues facing New Zealand. As you said, there are a lot of global issues, there are a lot of regional issues, and this particular platform is trying to look at our regional issues and hope to actually translate that to global, to actually solve global climate issues or environmental issues as well. So this particular program is led by Waikato University. It is funded by the Ministry of Business and Innovation and Employment in New Zealand. This has been funded for 7 years, and it's about, we've been given 13 million to do this. One of the things is we're trying to advance the state of the art in environmental data science by developing new machine learning methods for time series and data streams that are able to deal with large quantity of data in real time, and also how to deal with when we actually don't have enough data as well. It's built on a new open source framework and allows us to implement machine learning on it. So this particular collaboration is with between University of Waikato, Auckland, Canterbury, and Met Service, which is and Becca as well. So it's academic and industry as well. So this is one of our platforms, and one of our projects within the platform that I'm going to talk about is something that I'm leading. And this is using how we use information when we don't have enough information. And this is particularly with deal with one of the Sustainable Development Goals. It is about monitoring water quality. And what we've done is using satellite imagery and combine it with artificial intelligence to be used to predict whether there is harmful algae blooms in the water, which means that the water is toxic. So partially what we want to do is avoid or at least warn people not to drink this. And we want to actually be able to monitor the water. So traditionally, remote sensing is faster and a cheaper option for data collection, but sometimes it is very difficult. So one of the things that we've decided to do instead is that to actually use satellite data as a proxy. So we can actually use satellite data to look at how well we actually do, what the color of the constituents of the water is, and using that as one of the proxies of how well the water is doing, basically. The other thing that we have done is that we have part of the problem here is that what we've done is that there is limited labeled data, which means that typically what happens is for these lakes, an environmental scientist will go out and collect one sample, maybe once every month. You get about 12 points in a year. That's not a lot of data. So we've actually harmonize or actually use both the satellite data and using the semi-supervised, in a semi-supervised manner, use the labeled data to figure out how do we actually predict how the water is doing. So why is this hard? And this brings me to the second challenge when we're dealing with using data science, or third challenge actually, when we're dealing with data science for sustainable development goals. So researchers typically might work with large complex data set. Otherwise, they might also have poor quality data or data that is of very small quality. And we still need to be able to actually collect or be able to actually predict or use this to provide reliable insights. Otherwise, it's not much use at all in terms of prediction or modeling. So data is the lifeblood of the decision-making process, but what happens if you don't have enough of it? So one of this is how do we actually make data science better such that we can actually leverage what we can have now to make to solve current problems that we have. So one of the case studies I'm going to actually talk about is we've looked at one lake specifically. It's called Lake Waikari. This is a map of, this is Auckland. If you know Auckland, there's 2 islands. This is North Island, and this is a little bit south of Auckland. There's a lake right here, and we've looked at that. This lake is notorious for actually turning green for toxic algae in summer, which means that it is actually quite harmful at particular times. So what we've done is sorry. So what we've done is we've actually used this particular lake, and we've ran our algorithm over it, and we've actually tried to actually look at it. It is quite interesting in terms of what we found. It is very, very accurate. That is about it from my side. So in terms of looking at SDG goals, I've talked a little bit about what we've done. I've talked about the different challenges that we've encountered. So that's a little bit of my perspective. Thank you.
Okay, thank you so much for the very interesting presentation with the case study. So now we have Professor Cao, I think, need to leave. Okay, so I would like to thank you again, Professor Cao, for joining us today. I think he has to leave soon.
Thank you very much. I'm sorry for that.
Yes, thank you, thank you. So the next panel panelist will be Professor Masaru Kitsuregawa from the University of Tokyo. If you are ready, we'd like to hear about your perspective.
Hello?
Yes, yes.
So let me share my slides. Let me introduce some of our research activities, which is somehow related with SDGs. One of the biggest problems in SDGs, maybe currently, is so-called climate change. So we have long time developing the integrated data analytics platform for the Earth environmental data. So we started the 1980s, so which means around 40 years ago. So you can see the very old picture like this. Since I belong to the EE, we made a kind of receiving station with not digital by analog devices. And the very tiny mainframe machines, the main memory size just 2 megabytes. It's unbelievably small. And then storage is also very difficult to obtain. This is a storage systems for the satellite. The previous speaker mentioned about the importance of the remote sensing. Still, this is very important. And then in order to keep or maintain the big data, we have to build the storage systems by ourselves. And eventually, at this moment, our storage space is around 100 petabytes. This is not the university computing center at all. This is just one research lab in the University of Tokyo. So, frankly speaking, the computing center of University of Tokyo does not have such huge storage space. And this is distributed all over the Japan. Due to the global warming, heating problem of the machine, how to resolve this? We thought we should build a data center in Hokkaido, is more northern places. It is not necessarily important, but our emperors came to our research labs, and he presented this as a UN Congress. By the way, the upper part is all different kinds of the sensors, and the lower part is so many different kinds of benefit areas. So it's a silo, but what we try to implement is a kind of data platform which unify everything. So for example, global warming is one of the issues, and due to that, so water resource problem is major concern in the agricultures and biodiversities and so on and so forth. But the data which are available should be shared among the various programs as much as possible. So that's why such kind of integrated system, it plays a very important role. So we build 100 petabyte huge storage systems and application development software layers and so on and so forth. This is digital data explosion like this. It's exponentially increasing and increasing. And this is a number of users. Long time, not so many researchers paid attention to this climate change problem. But recently, so-called GX, green transformation is, many people believe this is one of the most issues. So that's why lots of people started to use our systems. Interesting behavior is half of the user is domestic, I mean Japanese researchers, and another half is from overseas. At this moment, 87 country people are using our system from the overseas. So it's intuitively, this system can be regarded as a kind of digital twin. So physical Earth monitoring data and so-called global circulation model simulation data, both of them are integrated into our system. And then by using these data, we will do some beneficial solution to the citizens. For example, let me introduce one of the recent activities in our lab is this green dots is a sensor. This green dot sensor measures the water level of the rivers. Actually, the number of sensors is so many, 15,000 stations or sensors. So many, you can see that. But this is a little bit expensive. So that's why we are currently replacing this sensor by the cameras. So many real-time live cameras stream is coming to our lab. And then we applied, Aaron Bin-san mentioned about applying the possibility of the AIs. And because image has more potential information, that's why this is very interesting. And so-called lots of layers of neural network. Eventually, we are reasonably well succeeded. And then this violet one is very dangerous situations. The red one is very critical situations. And the yellow one is bad situation is coming, and the white one is normal one, and so on and so forth. Such kind of classification working reasonably well. The other application I would like to show you is right now COVID-19 program. So we are not able to come to Africa, but before that we are working together with the African people, especially with the South Africa. The malaria boost predictions. So, for example, they have so many data. The horizontal axis is years. Vertical axis is number of the patient. So, due to the El Nino, La Nino, such kind of global Earth level phenomena, some year has a burst, other years doesn't so much patients, and so on and so forth. So we apply this kind of behavioral data using LSTM. We measured how we are able to predict rather precisely. And then we eventually get enough precisions. This moment, we are providing a service, and they are using a system like this digital iPad. And we are predicting which area has more dangerous situations and so on and so forth. And we are predictive kind of additional spraying, so on and so forth. In addition to Africa, we are working with lots of countries. This is the Philippines, the Myanmar. Myanmar is nowadays a little bit difficult situations. Sri Lanka's and Indonesia's and so on and so forth. So let me conclude the list of the problem. The problem is recently the fire and the rain volume is extremely serious compared to the previous situation. So which means kind of a zero-day attack in the security domains. So that's why the learning of the past events is not totally insufficient. So how to do these kind of things is an extremely big challenge as far as I understand. The next one is team science, which means the problem is so difficult and complicated. So which means just one researcher is impossible to do everything. So many experts has to join and work together. So what kind of platform we should build so that they work together more easily? For example, maybe you know about the world of the FAIR. FAIR means findability, accessibility, interoperability, and reusabilities. This is a keyword for the data-related open science. So findability is one of the most important part, but the vocabulary among the experts substantially different. So how can we share the data among the different disciplines? I think this is a kind of ontology problem or ontology inference problem and so on and so forth, still not yet clearly resolved at all. So that's why this is a kind of challenging issue. The third one is ARW, Automated Research Workflow. You might not be familiar with this word, but the year 2020, Nature Journal has this article, which is very symbolic one. The robot chemist. Sorry, let me show the pointers. So this is a robot, and the robots are working in the various stations and do the experimentation without any human intervention. So work for 24 hours. And the experiment efficiency improved around 1,000 times. So this is totally succeeded to find new materials by using this robot very, very short time. And in this year's May, US National Academy published one book called ARW, Automated Research Workflow. So the point is once human researchers are intercepted, then every cycle takes a much longer time. So the key point, whatever problem we solve, we have to pay attention to the how to reduce human interaction part. So no one is entered in these domains so much yet. So I think a huge opportunity or a huge research challenges here. So I would like to stop here. I listed up 3 problems, very extreme events, which are not easy to run from the ordinary machine learning technologies. And if AI doesn't work, the people has to do something. The team science, but one person has expertise area is somehow limited. How can fuse lots of expertise knowledge is very difficult and very challenging. That is the second. Third one is how to automate the research itself. This is a new challenging area. I'd like to stop my talk. Thank you.
Thank you so much for the very nice presentation, very interesting. So I think we don't have other panel speaker. The other panel speaker, I think, will not join.
So, Professor, other professor is the director of IIT Jodhpur. So he has urgent meeting with the ministry. So unfortunately, he could not join. Now we have panelists now. The floor is open for questions. If anybody has a question, we can take it. Yeah, here's the question. Okay.
I'll ask to Dr. Jaideep Srivastava, the idea that you mentioned about health and wellness is very interesting, because the classical definition of health itself as defined by World Health Organization in the late 40s is that health is a state of complete mental, physical, and social well-being, and not merely absence of infirmity or disease. So these are not 2 distinct concepts, they are one and the same. And when the problems that we see today is that any funding which comes is for healthcare, this is, as you rightly pointed out, channelized for treatment of infirmity or diseases, which is very narrow view of the world. So I wish your view, dominant view, is spread all across, and then hopefully we'll see some light at the end of the day.
Right, well, thank you again, for Dr. Polipalli for pointing this out, but and for that reference, to the UN report from some time ago. I think every society has understood that health and wellness are obviously integrated, but it is just what shall we say, the economics and politics of societies and very often professions that has created this dichotomy and funded one side of it and very often not the other. And sometimes I'm sort of almost sad to say that those who only take care of healthcare in its the emergency form, the business model is that wellness better not be too good, because then it's like sometimes I tell my doctor friends that you guys your ambulances are like, you want some cars to break down on the road so then they can come to the repair shop and be pulled by an ambulance, by a tow truck. So but I think there is realization is dawning upon people. So there are some efforts going on to have an integration between the two.
Hello, everyone in the panel. So I'm actually a working finance professional. I'm outside of the tech domain. So I have a generic question, you could say, on the use of technology for SDG purposes. So it's while it's really enthusiastic to know that tech can solve so many problems by utilizing all its power and all, but have we thought about it, or are there any researches or efforts going in the direction where tech also has its own set of environmental problems, such as generation of e-waste, or even the power consumption, and also even the heat generated, which is having the impact on the environment. So are there any works that is being done on that side? Just wanted to know, curious. Thank you.
So who is going to take this question? Let us start with anybody. So question is understood, or I hope. What is your question again?
So basically, I just had a general question regarding the other side of using technology for the SDG goals of attaining the SDG. I think one of the major goals is towards on the environmental side. So using tech also has its own environmental factors or concerns like generation of e-waste.
Yeah. What he's saying that you can extend the technology for sustainable development goals. In the due course, you can also generate e-waste. That's your concern.
E-waste, as well as utilizing generating heat because of using
heat during
due to capacity, computing capacity, especially on mining of cryptos and all.
Yeah. So that kind of question. So Sir Jaydeep, you can take her.
Sure. Okay. Well, absolutely. So I think to the first part, I would say that all of these problems are societal scale problems, and in fact, in many cases, they are species scale problems. If you look at just the COVID, right? COVID was not a problem of actually, it's not even was. It still is with us. It's not a problem of a country. It's not a problem of a society. It's a problem of the entire species. Okay, so when you're looking at problems at that scale, technology is one component of it. There are all the other things, like from economics to politics to legal frameworks to whatever else, right? So all of these, so technology has its own role, and sometimes it's maybe even a very minor one, a very small one. So that sort of that, yes. So the answer has to be technology has its role to play. I think what technology helps us do, especially information technology, I would say, it helps us. Since we're talking about since this is a data science panel, one of the things that data science does is it provides us a way of being able to separate myth from fiction, from fact. Okay. We have a lot of mythologies we live with, a lot of gut feel and opinions and expertise built upon nothing but just opinions. And it says, no, well, let's go and check the facts and the data, right? Statistics has classically been called as the conscience of science. So that is one of the most important roles that this can play. Data science or technology of this kind, information technology, can play in solving these problems. That means laying things out, trying to bring them closer to science and reality as the way things are, rather the way things people believe them to be. Okay, so that's one part. Coming back to e-waste problem. Yes, e-waste is a problem, as is energy that is the heat that is generated. But I would say that but we have to always look at the different kinds of wastes and different kinds of warming or heating generated by different sources. I would say e-waste, while is a big problem, there are many other kinds of waste which are far bigger on the pile. If you take all the different kinds of wastes and drop piles of garbage, if you will, e-waste is not amongst the top few. Okay, it is significant enough. And as far as energy generated by data centers and so on is concerned, there are many other sources of and let us look at all the energy generated and as causing global warming, for example, or climate change. Things like transportation and so on come up much higher in the pecking order than the heat generated by data centers. So I would not worry about that as a big source of, let's say, global warming, if you're concerned about that.
said like the energy consumptions of the collected data centers across the world is almost stays at 1/5. In terms of the country's usage, it stays at 1/5. Okay. So in terms of the data analytics, and then like, say, for example, data science is concerned, the amount of energy which you are consuming to do this sort of analytics, okay, it is pretty huge.
Okay.
So basically, like, there is a lot of research which is actually going on. How much energy you are actually utilizing to basically extract any knowledge out of the data which you are actually trying to generate. So there is a lot of research which is basically going on how data centers can reduce the amount of energy which they are using. And then, like, say, for example, they're also using some technologies like IoT technologies, etc. Say, for example, a data center which is really getting heated because it is doing a lot of computation. Okay. So some of the things are actually live migrated to a different data center. Okay. Or like, say, for example, a data center where like only some number of nodes are still functioning to do any sort of analytics. They are live migrated to a place, okay, so that like we can switch off some of the data center servers, clusters, etc. So there is a huge research which is actually going on that one, which is actually answering your question. Okay. Thank you.
Any other question? Anyone you want? Yeah, here Uday wants to.
So thank you very much, panel. My question is to Kisturigawa Sensei. Kisturigawa Sensei, can you hear?
Yes, I can listen to you.
Yeah, Kisturigawa Sensei, I have one question to you. So DIAS is currently storing the data from the real world applications, but assume we are developing a mathematical model, a simulation model to produce the data set. Like we are thinking of some application, maybe 10 years from the current future or 20 years from the current future. And we are creating some vast synthetic data sets. Okay. Does DIAS offer the flexibility or scope to store these hypothetical data sets?
Okay.
Yeah, hypothetical. Synthetic or hypothetical. Hi.
Yeah, there are so many kinds of the data we do have. So one is observation data. So this is a kind of factual data. But as you know, IPCC is now a kind of global warming prediction. And so that's why that kind of data is a kind of hypothetical data. I'm not sure you know about event attribute. So what, for example, one extreme event happened. So big hurricanes happened. Whether this event is actually caused by global warming or not, that is one of the most important research topics, and many people are working on that. At that time, we prepare the global warming prediction data as much as possible. And then we compare if the global warming never happened, how we predict. I mean, the difference between warming situations and non-warming situation and so on and so forth. So we are using a lot of hypothetical data, and that no one knows, but IPCC is trying to do those kind of things. However, the hypothetical data means I presume you are worrying about so-called ensembles. So many ensembles that occupy the huge amount of data space. And how much we are able to keep is one of the biggest headache. So, not yet solved. So that's why I think a previous speaker mentioned about how to reduce energy for the data centers. And that kind of thing is actually becoming very serious for us. how much precision we are able to achieve, but we have to pay a tax to use energy rather big. So it's an unsolved problem. Is it okay for your question?
Yeah, I think that's okay. So I have one question actually now. You said that one person is not sufficient to solve the big problem. And normally many data science researchers are working a lot of machine learning problems, data science problems, but not on sustainable development goals. How to make many data science researchers to take up these problems? I think if many data science researchers come and take the problems of sustainable development goals, I think we will find more effective solutions as soon as possible. So research question is that I find it difficult to find the panelists also to speak on this topic. A lot of rejections after sending to several experts. Finally, you four agreed. Why such a situation exists and how to correct the situation? What are we supposed to do? I start with Professor Yun Sing Ko. First, you comment on this one. I will take comment on it from everybody. Then we close the panel, I think. How to get more hundreds of data science researchers to take up problems of sustainable development goals. Maybe hardware, maybe software, but the aim the problem should be sustainable development goals. You start with Professor Yun Sing Ko.
Okay, so I think it's a mindset thing. Like if you want more data scientists to actually be working on SDG goals, then you'll need to sort of promote it. I think it has to come from the top. I think if as policymakers, practitioners, stakeholders, you're really interested in it, you'll most probably get a lot more excitement trickled down. So being able to actually promote using data science for the SDG goals can really support this achievement of actually encouraging and mentoring and nourishing the next generation and data scientists to actually train in this area. Potentially the understanding that it's actually not easy. It's never easy to actually work in an I want to say interdisciplinary. Now I like to say actually transdisciplinary, because a lot of the efforts that we put into actually working with different expert domains means that there is a different mindset shift that you have to actually be able to cope with. You have to actually be able to look broadly at the implication of the work, also to actually understand where everybody is coming from. And the co-design part from the very beginning is hard. So being able to actually facilitate that, being able to actually encourage that, and be able to work jointly to create new conceptual, theoretical, methodological translation of innovation. That's something that's actually quite exciting. In general, I just think people should do it. It's just me.
So, Masaru Sensei, you can continue next. What is your comment actually? Yeah.
I totally agree with Yun Sing Ko-san. She said the problem is human beings' mindset. I totally agree with you. Why people buy cryptocurrencies? That consumes a huge amount of energies. It's ethically totally incorrect, but this is a really human being. So changing the mindset is one of the most difficult part. We don't know how to do that. I think one of the way, for example, you know, the phenomena so-called Brexit, why this happened. And this is done by Cambridge Analytica. Slightly change the people's mind using the Facebook. So this is not so good, but for the environmental problem, maybe we have to use such kind of a methodology to change the mindset. We don't know. other methodology at all. I'd love to listen to the opinion by Yun-Sin-san. What's the real methodology do you think?
Thank you. Jaideep, Professor Jaideep, you want to comment on that one? So how to encourage more data science researchers to take up these problems actually?
Right. Okay. So I think that, I will. Okay. So I would say that there has to be a note of encouragement, but also to some degree caution, which is that as we've been discussing, one of the main themes we have heard also is that these problems are large, big problems having many, many different components. And very often components like economics and politics and so on, they drive the agenda rather than the data science part of it, right? So the part of it is that only organizations, only large research teams led by distinguished not just scientists but also administrators, like one of whom we have right here, our friend Professor Kitsuragawa, right, are the ones who can lead such efforts. And it is for a young data scientist, I think it is important for them to become part of these teams, and then only there's a chance of doing that. So the encouragement part is, look around at the problems that you're interested in, problems that are also relevant in your own context, okay? Relevant in the environment that you exist, relevant to the funding agencies who might be funding your work, whatever it is. Then also look for the appropriate organizational collaboration, and then go ahead and make the connections that is required, because only larger organizations with a lot of people of complementary skills and connections coming together are going to solve this problem. So that is the note of sort of both encouragement and caution. So it is caution. Don't just start out on your own. Do not be an American cowboy. Do not. It's not going to go anywhere. And make the right set of connections. So that's the note of caution, but also the encouragement is that if you do that, you will find that people will welcome you, because that way you will also understand and get the appropriate sense of maturity and the role that data science can play, and understand the whole thing better. And in fact, many of these problems, solutions to these large complex problems, they build upon skills of various kinds, and therefore it has to be done. In fact, one community that has always done that extremely well, not for sustainable goals, but for pure physics, is the high energy physics people. High energy physics people have always known that the whole world will not give them two super colliders at one shot, only one, right? And that too once every 20 years, once in every generation. So they know that, well, once CERN was created, after that, next one, who knows when the next one will come, right? So they know that the kind of expertise and resources it requires to remain at the cutting edge of science has to be where everyone gets together. So that whole notion of collaboration has to be there. Otherwise, it cannot, we cannot think about this, okay, data science, what I'm a data scientist, what is the problem I should solve? Well, first of all, you have to figure out which overall problem you're trying to solve and what is your role in it and who will you play with. Once you haven't figured all those things out, there's no hope of actually solving a data science problem in it.
Okay. Any comment from the audience? We are keeping this open. Sanjay, you want to say anything? Yeah. So, Mike, you can. Where is the mic? Yeah.
Okay. Thanks, Jaideep, and good afternoon, Professor Kitsuragawa. I'm Sanjay Madria here. Good to see you. Good. So my question is, I think you have touched upon, one of these issues. Like when we work with data scientists and across the domain, like we have people from engineering, we have from social scientists, We have people from, of course, science, and everybody looks into the same problem very differently. Like social scientists is looking what impact this will have on the society, right? The science guy is looking, okay, how he can bring some novel ideas, right? And the engineering guy is looking into, like engineering side of it. So bringing all this together is, to me, looks sometimes difficult. That they all have to understand that we are trying to solve the same problem, right? It's not trying to solve different, it may be some different sub-problems, but overall everything will come together to solve one problem. And that's what sometimes I see when I talk to them, that they, or maybe even I don't want to understand, for example, like how they will look into the same problem. And then I'm just trying to see what I can do, and I'm saying, okay, I'm going to develop some models for this problem. They look into something very differently. And sometimes that's the problem, that these are like different pieces, how you put together. Any comment?
Yeah, so we'll take comment from each one of you, then close the panel now. Just 1 minute. And finally, we start from Yon Singh, Professor Yon Singh Kaur. So you understood the question. So what is the difficulty in?
Yeah, what's the difficulty in the discussion between different domain experts? Basically, that's the question. Yeah, okay. Yeah. So I think one of the things is sometimes it's the language. And from my point of view, it is everybody has that one goal. They know what the outcome should be. But the translation and language, how we get there is very different for different researchers. So being able to be able to do that, one of the things is you need to be flexible in terms of how we are dealing with other researchers within the field and be able to actually look at it from their standpoint. Ultimately, I think everybody going into a project knows what the outcomes are and what they really want. It's just a journey getting to the end point.
Okay, thank you. Masaru Sensei, you want to go through? Just what is the difficulty in, you find with working with other domains?
Sanjay-san, thank you for fantastic but extremely difficult question to us. But I already mentioned about the importance of the team science. And in that case, I already mentioned the difficulty in vocabulary set. So vocabulary harvesting is critical issues. But frankly speaking, but I think having different knowledge from different expertise area is very important. Let me introduce one example. For example, Yoon-san mentioned about the importance of the, say, remote sensing, right? But for the remote sensing researchers' point of view, the crowd is horrible issues because we are not able to see the ground due to the crowd. Right? However, recently, many people are now doing the research on the crowd. Why this happened? Because many people are now using a so-called PV. PV means solar panel. The solar light is go through the crowd, right? So that's why the physics of the crowd, their interest is totally changed and different. So different expertise has to be fused or integrated in solving such kind of creating renewable energies. So I think if we don't have a variety of expertise area, it's very difficult to create very difficult for us to predict what kind of solar energy we are able to produce tomorrow. However, now it's becoming very, very precisely possible. So which means the different expertise is very important. In this case, we don't need to communicate so much. So I think case by case, Sanjay mentioned about the difficulty of the communication. I totally agree with you, but decomposing the problem in a disjoint set, by which I mean the expert do not have to need so much intense conversation. Maybe such kind of problem decomposition is very important. Thank you.
So we will have final word from Professor Jaideep and close the panel. Thank you. So what is the difficulty?
No, you're giving me the chance of speaking the final word. I don't know. That's a big responsibility. But I will limit it to just this this particular thing. So I would say, Sanjay, to answer your question, different fields of computing research have different burdens of understanding the application domain. So, for example, if you work in computer networking, in some sense, you're like a plumber. It doesn't matter. You're making sure that the stuff flows through the pipes. You're never going to, or like the postal service who never opens the envelopes, right? So it doesn't really matter whether water is flowing in the pipes or oil is flowing in the pipes or whatever it is. But if you're a data scientist, you're actually working with the material that is going through the pipes. So you have to understand that the nature of water is different than the nature of oil. And what people use do with that water or what people do with that oil is very different. And again, whether oil, it's vegetable oil for cooking or it's petroleum for gas. So the point is that those of us who are working, or anyone who's working as a data science person, who's working with understanding the data and building models and so on, they cannot be divorced from at least some level of understanding of the domain. So it is almost a responsibility. And to those who are not interested in trying to understand the domain, work in computer networking. Then you don't have to worry about that, or go work in computer architecture or disk design or something like, the hardware stuff. It doesn't really matter, right? So, but at the same time, from what Masaru-san said, that if you're talking to the physicists as a computer scientist or a computational person, and suddenly something changes over there, or the climate people, you would be at the cutting edge to understand when they have something new that they have come up with, you're the first one they will talk to. And you have an opportunity to design algorithms that none of your other, and models that none of your other friends in data science would even give the wind off till you have written those first papers and published them. So talk to people. You will all of a sudden be the first one to write papers in these transdisciplinary applications of data science, that you are the one who will then go ahead and introduce those new problems to the whole data science parent field. And then your papers will be referenced by everyone because those are the first one to introduce them. So it's a challenge, responsibility, and also an opportunity. But as I said, if someone does not like that, go work in computer architecture or computer networking.
Okay, thank you actually for your information. There are about 60 people seriously listening to your speech here in the hall. It's at 5 o'clock. Your talk panel is streamed online. I don't know how many are visiting online. So thank you very much. Finally, I give your dice to Philip to say final word, and we'll close the panel. We exceeded 3 minutes. It's okay. Thank you.
Okay. So I think we had a very nice panel. I would like to say thank you again to all the experts on behalf of the conference. I think we saw many different perspectives about the case study, the environment, the health, and so on. Very interesting. So then I would just like to say thank you again. Okay.
Thank you. Thank you. Yeah, again, clap it. Thank you. Thank you. Bye. You can close it. Just after this. Switch off.